Hello grade 12s, welcome to my channel. Let us finish off on differential calculus. So we will wrap it off with optimization. Of course guys, I just want to get straight to the point. What is optimization? This is when we consider maxima and minima. Okay, so we're going to be dealing with stuff relating to turning points. Because once we say maxima and minima, if we're talking functions, it's going to be related to turning points, but of course many other issues. But these are somewhat going to give us an idea of functions and in particular turning points. So there's three things that we need to know when we talk optimization. We're going to be examined on measurement. Okay, so we're talking about perimeter versus surface area versus volume. So this applies to both 2D and 3D shapes. Okay, please know this from grade 10 up until grade 12. Of course, with a bit of some simpler versions of this from grade 3, if you will. Right, so we will consider these as we go along. Again, folks, as I said, functions, very important. So do not forget. So for curves, this relates to turning points, okay? And for linear functions, we may look at some sort of restrictions that in the end we can talk about maximizing and minimizing whatever we see there. Of course, usually this is on the vertical distance between two functions. This is when we say that distance is going to be y top minus y bottom. Okay, this is for the same x value. Okay, so usually when we deal with functions, it's going to be relating to turning points and the vertical distance between two functions, where we're going to focus on this formula. The distance being y top minus y bottom for the same x value. Okay, so these are the things, folks, that you need to consider. So this means when you want to master optimization, you must have mastered these topics I'm highlighting. Then there's something rather peculiar to you guys in maths, because you normally don't deal with this except for those who do physics. From grade 10 already, they know about speed. So speed, we're talking about the rates of change, right? So we're talking about speed and acceleration. Okay, so speed by definition is the change in distance over change in time. Acceleration is going to be the change in speed or velocity divided by change in time. So these are the rates of change. Okay, now this triangle helps a lot sometimes to deal with issues of speed. So this triangle helps a lot in this regard, because we can say, fine, if we're looking for speed, we know that speed is going to be distance over time. And if we're looking for time, it's going to be distance over speed. And if we're looking for distance, it's going to be speed multiplied by time. So do not forget this triangle. It helps a lot. Okay. Right. So what additional information, folks, must you consider? Because remember, these topics are very interesting. So we have to consider some additional info that may be helpful. So remember all the theorems in geometry and their corollaries. Okay, very important, because they apply in this. So do not think because this is paper 1 related topic, a concept from paper 2 may not be examined. Yes, probably not in the sense of paper 2, but its application would be appreciated. And of course, folks, do not forget trigonometry. Okay, this is from right-angled triangles to non-right-angled triangles. So meaning we need to know basic trigonometry in terms of trig ratios on a right-angled triangle, as well as using the triangle rules, because as you saw, there would be questions on measurement, areas and stuff. Sometimes you may have to use the area rule for example, or to find the perimeter you may have to use the cosine rule or the sine rule to find the sides and then do the perimeter eventually. Fine, so that's good. And of course, guys, we need to understand word problems. Again, this is not such a common topic lately. We used to have a section dedicated to this in grade 11, grade 10, grade 9 or so. But nowadays, I don't see this topic consistently coming up. And in fact, if you think about NBTs, this is the AQL part, because this is where we can use English language in mathematical sense to develop or to model equations that we may later solve accordingly to then answer a pressing problem. And of course, folks, remember the utility of simultaneous equations is never to be forgotten, because most higher grade questions will involve simultaneous equations, because these are by definition the most indirect questions you can find. So at some point you will have to derive a set of equations that you may then solve simultaneously to then get around the problem. So this is basically, folks, the few things that I suppose you must have in mind. Of course, I cannot exhaust all of these. All I want us to do is to get into business. Now let's take our first example. We are told that the radius of a solid base metal cylinder is X centimeters. So this is again a topic on measurement. So if we can assume this is the center of our solid, so this means from center to circumference, we're looking at X centimeters. So that would be the radius. We know that it's from center to circumference, nothing else. While its height is 300 minus X centimeters. So this means this dimension all the way to the bottom is 300 minus X centimeters. So again, folks, it helps to know these basic shapes. Okay, now the first question says show that the volume of this cylinder is as is given. Now remember, we are told that this is a solid base cylinder. So we want to know how much space can it contain. Okay, so let's deal with it, folks. So first we're going to say answers. For A, we know that the volume of any structure is going to be the volume of it's going to be the area of the base multiplied by the perpendicular height. Remember, this is not relating to surface area, so we don't worry about other things. So we know that the volume V is going to be the area of the base, which is pi r squared, because remember, we were told it's a solid base to suggest that it's not open. Okay, secondly, we then multiply this by the perpendicular height. Right, so volume V is going to be pi. The radius is X, then it's squared. The height, we were told, is 300 minus X. Okay, cool. So what we need to do now is to FOIL everything. So therefore V is going to be, now remember, this is X squared times pi. When we multiply this by 300, we're going to get here 300 pi X squared, okay? Minus, we multiply that whole thing. So we essentially distribute this into the first term as well as distribute it into the second term. Okay, maybe it's not going to come out nice. Perhaps like that. So what are we going to do now? Yes, we're going to have here basically pi. We're going to have pi x cubed So this is done. So as you can see, guys, it's very easy. It's very easy, not a complicated scenario. Excuse me. So of course, folks, substitutions that are correct and the final answer. You may walk away with just 2 marks here. Okay. But sometimes, because the formula here is somewhat important, some persons may say 3 marks. Of course, we can say plus or minus. Okay. Cool. Let's have a look at B. B says determine the dimensions of the cylinder with a maximum volume. Now, what do we mean by dimensions? This is the radius versus the height, because that's what is important here. We're not going to be looking for the circumference. So this means solve for x. Okay, so let's do it. So now how we're going to do this? We said maximum volume. Now this means we're going to treat this. Remember, this is a cubic equation or cubic function. So all of these things model functions. So we're going to say find for maximum volume this is to suggest that dv over dx must be equal to 0, isn't it? The derivative must be 0 if we are to maximize this. So what does this imply? We differentiate there. So 300 by 2, this gives us 600 pi. Then from x we subtract 1. So this is good. Minus, this is going to be 3 pi x squared. Now we're saying this must be equal to 0. All right, so what are we going to do? We factorize. The highest common factor here is 3 pi x. So we're going to have 3 pi x into, then this is going to be 200 minus x, isn't it? Which is going to be equal to 0. So we can already see that technically x is going to be equal to 200. Now remember, this is centimeters. So we've solved for x. X is 200. And what would be the height? Therefore h, because we were asked the dimensions. So remember, this is 300 minus 200, which gives us 100 centimeters. So very important stuff. Otherwise, a very simple question, if you ask me. So this is it. This is it, folks. So again, we look at what we're supposed to do, equating the derivative to 0 and taking the actual derivative and calculating these. So this would be an easy 4 marks to score. So now here's what is important to remember, is that we need to use our knowledge of measurement, be it volume, area, whatever, to find a particular equation, which is modeling. We're modeling here a cubic function, so to speak. As you know, volume is going to be a product of 3 sides. So most likely it's going to be something cubed. So this is a cubic function. So if you think about it, volume most probably or almost always is going to be modeling a cubic function, because you're multiplying a certain unit by itself 3 times, which means it's a cube of something. A square, it's a quadratic. So think about this way. If you're thinking about a square root, sorry, not a square root, but if you're thinking about a surface area, this is more like a dimension multiplied by another. So this would mean a quadratic equation. If you're talking volume, this models a cubic function. And then if we're thinking about a straight line equation, that would be a perimeter, for example. So if you think in this sense, guys, you will never go wrong, because you would already know that these are familiar functions, as I said in the opening of this video. Okay, folks, let's not sit too much. This is how easy it can be. 7 marks up to 10 marks, usually this topic. It's never really that hectic. Now let's have a look at a situation when we have a function now directly, or should we say just functions. Because now these examples are just trying to show you examples of 3 situations or scenarios that we said. It's going to be something relating to measurement, which we have done. And you know that perimeter models a straight line. We know that, or in fact, we can say perimeter is modeled by a straight line function. Area is modeled by a quadratic function. And a volume is modeled by a cubic function. Now we're going to look at some functions because they can be any of the functions that we know. I still am going to give you guys a video on some deeper sense relating to each individual function that you have studied up until grade 12. So that video is still upcoming. I just left you with the basics, which I hope you have learned and understood. Now let's get to this question. It says the diagram shows the graphs of the straight line x plus y equals 4. So obviously this is a straight line equation, but not written in the standard form. So for you students, you need to be able to write this equation in standard form or in the familiar form. It helps to do that because that way you uncover the y-intercept that it is at 4. Okay? And what does that mean? Also the x-intercept is at 4 for such a function. So again here, you don't need to be showing us for x-intercept, it means x must be 0. You just look at the function using your knowledge that you've acquired so far. You can just see those things without being told where they are. Then there's a hyperbola as well, which is xy equals 9. Sometimes you may not even give the indicators that these are straight lines and hyperbolas. You can just say these functions, g of x is, f of x is. If you look at it, it's a hyperbola because again, if you isolate y here, you're going to have 9 over x. Okay, but now there is a restriction here that for this function, x must be greater than 0, meaning we're just choosing one component or one portion of that hyperbola. As you would know that the other one would be in the 4th quadrant over there, so we don't have it now. Okay, so that's fine. So the question says now, the line segment PQ is perpendicular to the x-axis. So as you can see there, it's indicated that this is perpendicular to the x-axis. So what does this mean? It means the x value at Q is the same as the at P is the same as the x value at Q. As you can see, I've already indicated this. Actually, I should not have indicated this before we solve, because when you get this question, it's not going to be given like that, okay? But the y is certainly different, and the y is also different there, okay? Cool. Now it says calculate the smallest possible length. Now, folks, once we say smallest, what does that word mean? It means minimum. So again, AQL kicks in here. Academic and quantitative literacy needs to come in. So we're going to try and push you guys around. So what are we going to do, guys? We know that it's going to be the function at the top minus the function at the bottom. So we know that PQ is equal to the y at P, right, minus the y at Q. So this implies that PQ is, the y at the top is actually the entire function, isn't it? Because that's the y that we're saying. So this is going to be 9 over x minus, now what is the y at the bottom? That's the function there. So this is going to be minus x plus 4. So as you can see, understanding functions is important, guys. So we can say safely, therefore PQ is, we can already see that we don't want to differentiate here because We are told smallest, so that means we're going to differentiate. So we set it up. So this is going to be 9 times x to the minus 1. Remember, we prefer not to have variables in the denominator. So this is going to be plus x minus 4. So that would be the function for PQ. Now we differentiate. We can say for minimum distance, it will be such that we take the derivative. Now folks, what are you going to say? I'm going to say, well, d PQ over dx. Or you can just say d over dx. You don't even have to mention PQ at this point, but let's just continue. This should be equal to 0. So this implies we differentiate. So this is going to be minus 9 x to the minus 2 plus 1 is equal to 0. Remember, the constant falls away. Remember the rules we learned. Now we need to solve for x. We can't solve for x in this manner. So we convert it to exponential form. So this is going to be minus 9 over x squared. We want a positive exponent. We transpose 1 to the other side. So this becomes 1 over 1. You see how nice this is? Yes, it is very nice. Now you can already see this is going to be a difference of 2 squares, is it? Yeah, it's going to be a difference of 2 squares, because now what we need to do is cross multiply. So you need to understand algebraic manipulations, folks. So this implies that we've got minus 9 is going to be equal to minus x squared. So we're moving around nicely. Now if you like, you can just multiply by negative and then take a square root, but you know what, let's just play with the algebra. We move the x squared back, so this is going to be x squared minus 9 equal to 0. This also implies that we can factorize, just so that you can understand that the algebra, guys, never leaves, because most of you take this for granted. So what do we say here, guys? Therefore, x is either minus 3 in fact, it's 3. Why am I ignoring the negative? Remember, this is the positive axis. X is positive here. So I cannot consider this negative, because the negative, it means it would have been a situation somewhere there as well. But now we're not looking at that, okay? So already from just looking at the graph, again, this is to say know where to look so that we can do this. Now, what are we supposed to do? We're supposed to finish this off. So now I'm going to finish over here, just so that we don't waste space. So we can say then PQ is what? Is 9. Where we see x, we put a 3 to the minus 1 plus 3 minus 4. Therefore, PQ is going to be, let's just do it on the calculator. This is as good as 9 over 3, right? Which is 3 plus 3, that's 6, minus 4, that's 2. So we can just say 2 units. So very easy, but of course you can put it on the calculator. It won't hurt at all. But be quick with the maths, guys. There is no excuse you can make here. So this is 2 units because no measurement was specified, whether this was in centimeters or in whatever. Okay, so this is cool. So optimization, guys, is easy. It's nice. As long as you know what to do, you are good. So basically, you get a mark for finding a function that is PQ. Okay? Right. As to what type of a function this is more of a as you could see, we got two values, so that's a quadratic equation, but it doesn't appear as one. But if you look at those higher order algebraic questions I gave you in this channel, please try to find those videos. You will see that quadratics sometimes don't look like quadratics, but as you go along, in fact it's a cubic, I suppose. It looks like it's a cubic because when we differentiated, we got a quadratic. So this means this is a cubic, right? Because, yeah, it must be cubic. Although it doesn't appear to be cubic. But remember, whenever you differentiate a cubic, you get a quadratic. And you could see that when we differentiated here, we ended up with a quadratic. But the second possibility is that because this is rational, you could easily say this is somewhat a hyperbola, because even when you differentiate a hyperbola, you somewhat get a quadratic as well. Okay, because yep, it is parabolic as well. As much as we say hyperbola, it's technically parabolic. It has a curve with some sort of symmetry around a particular point. Anyway, let's not complicate anything. So first of all, to differentiate and equate the derivative to 0, very important, x value and the answer. So as you can see, this one is one of those questions where you score some plus or minus 5 marks for your troubles. Okay. So please know functions, folks, and please know how to deal with issues regarding functions. Now let's come to a question 3 or example 3 where we can talk about the rates of change, because these questions are also part and parcel of your exams. Now, told here that a projectile, which is a flying object in general, but in physics, you know better than to say it's just a flying object, okay? Is shot up into the airframe. Sorry, is shot up into the airframe. I think here I wrote something crazy. Can't be like this. Here, what happened here? I didn't read what I wrote here. Is shot up into the air from the top of a cliff. That makes sense. So yeah, it's shot up into the air from the top of a cliff with an initial velocity of 100 meters per second. Basically, from this statement, you can already see the definition of a projectile. Right, so then the displacement of the projectile from here. The displacement of the projectile from is given by the formula. Okay. Looks like, guys, here I didn't read what I wrote. I just wrote, can say from the cliff, I suppose. I hope so. Okay, the displacement of the projectile is, maybe I should just say that, because it doesn't matter from where this is, but I think you can just easily say the displacement of the projectile is given by, just to avoid issues. Okay, so by the formula, I think here that from was supposed to be there, but there was a bit of a mixed masala. Okay, it's 100t minus 5t squared, where s is the displacement in meters and t is the time in seconds. Can you imagine here? And when they get done up, anyway, you know, there's applications. Whatever you do, sometimes you do it well, and then if you mess up something, changes everything. Okay, so upward direction is taken as positive, as you would see in physics, that this is often the case. We have to choose a direction. So this question is very good for physics students, but for those who don't do physics, you may struggle to figure out what to do here. But anyway, stay with me. Calculate the velocity after 5 seconds. Now, remember, when we model a projectile, it is a parabola, right? But you can even look at the formula given. This is parabolic. It's a parabola, but what type of a parabola? A grumpy face parabola, because the coefficient of the highest power, which is t squared, is negative. So this is a grumpy face parabola. So if you already know this in physics, you can do it. But even if you're doing maths, you can already see from the equation that this is modeled by a quadratic equation. So let's get to business, folks. Answers. Right. 1. First of all, I think it helps for us to perhaps give the sketch. Sometimes I prefer to draw a sketch. Now you will see, guys, that if you don't master functions, as I said, you will be in trouble in this topic. So this is going to be the t-axis, and this is the displacement s, and this is 0 over here, the origin. Now, we are then asked to find this after 5 seconds, and upward is taken as positive. So this means we are going to use the starting point as the reference. So this is a parabola like this. It goes up, comes back down, but it may go past because this is a parabola, right? Remember, the starting point is the cliff. So this can go up, come back to the same level, and then go down to, okay, I don't like this parabola of mine. It doesn't look convincing. That's much better. So we know that this can go further down up until it hits the ground or the sea or whatever is at the bottom. So it helps again to have this in mind. So why do I know this? Because I'm looking at that. And again, if you solve for t here, the x-axis, the x-intercepts, it's already going to be 0, right? Right, because we just make s, which is y, 0. So if we solve here, we're going to have to take out 5t, right? So when we solve here, but again, you have to be able to just look at it and see. So if we decide you're going to take minus 5t, then all we have left is t. This one becomes positive. The other one becomes negative. Now, what times 5 gives us 100? It's 20. Right? So this is going to be 0 and 20. Okay, cool. So that's as good as that. So those are the intercepts. Again, you can just look and see for yourself. All right, let's start answering the questions. Number 1, we need to determine the velocity after 5 seconds. So what is a velocity, guys? It's a change in distance over change in time. So this means it's the gradient in 5 seconds. So what is the gradient? We differentiate the given equation because it was displacement time graph. So the change in velocity, or should we say the change in displacement over time, is going to give us the velocity. So that's exactly what we're going to do. So we know now, okay, we just are interested in our d is it dt? Yeah. First, that's what we need to do. Then we know that, okay, the velocity is going to be like that when t is 5. Okay, but let's just start with this one. When we differentiate, what is it? Or maybe let's say that the velocity itself is going to be equal to d over dt, right? Which we can differentiate that expression. So this is just going to be 100 minus 10t. Okay, now the velocity after 5 seconds, we can say then velocity after 5 seconds is equal to 100 minus 10. Where we see t, we put 5. What is this? This is 50. 100 minus 50 gives us 50. Remember, this is in meters per second. We cannot forget to do that. Okay, so I hope you guys can follow. If not, please shoot a question. So why do I know velocity? Because velocity is a change in distance or displacement over time. So this is a type of a graph that I'm hoping for. So that's the gradient at 5 seconds of the displacement versus time graph. So I hope you understand. So if we assume this is where 5 seconds is, the gradient at a point is a derivative, isn't it, of the function. And we can say maybe this is 5 seconds. So always picture this as a function. Although we're dealing with rates of change, so you need to be able to understand what is going on. So the velocity function is going to be this. This will model any gradient everywhere else. All that changes is the time. So you will just use that expression for whatever time period you're looking for. Right, so let's mark this. So of course the derivative is important, guys, and the answer. So you would get 2 marks. Some people may also consider the substitution. Sometimes we may, sometimes we may not. It doesn't matter. Let's not stay too long. Second question says, determine the time it took to reach maximum height above the cliff. See, again, this is to suggest that we are looking at the time here. Because at maximum height, we know that the velocity is 0. Why? The gradient is horizontal there. So if you did not master this, you will never understand it. Because we know that, okay, at maximum height, which is the turning point, the velocity of the function, or should we say the gradient of the function, is 0. Right? Which is the velocity at maximum height in general, or in physics, if you think. Okay, so let's look at this. So how long did it take to reach maximum height? So again, folks, we are literally looking for the time when the velocity is 0, meaning the gradient is 0. So we're going to say, fine. All we're just saying is that technically at this point, we know that d over dt, that is the velocity, must be equal to 0. Now, this implies that our 100 minus 10t is equal to 0. So as we move things around, you can see that t is going to be, transpose that, it's positive, you divide by 10, this is just going to be 10 seconds. Nice and easy. Nice and easy. So this means this is 10 seconds. Right. So can you see we're using the knowledge of a parabola here to then answer these questions, because they are now an application of what you would have had as a parabola. So again, to know that this must be equal to 0, or even here, I think it's better here, and you get 2 marks. Very easy. So that's very, very, very important. So it took 10 seconds to reach maximum height. Now, third question says, calculate the maximum height above the cliff. So again, we want to know what is the corresponding y value of the turning point. Now, you can either use the knowledge of a turning point here, or you can, you can just, substitute into the equation, the original equation. Now that we know the x value, so we know that the s, which is displacement, is equal to 100. Instead of t, what are we going to put? 10, the one that we just calculated. Minus 5 into 10 squared. Right, so we basically just substitute the x value into the function. So this is more like finding the y value at the turning point, since we know the x value, okay? So we can say therefore the displacement is, now this is 8,000 minus 500. So this is just going to be 500 meters. Okay? Very nice, isn't it? This one is excellent, excellent and brilliant. So to know what to do, guys, is key. Answer, or you can just say answer only 2 marks. But I'm just using these questions, guys, so that you can gain an easy understanding, because some questions may not be as friendly as this one. But this one is meant to develop your muscle here. Remember, to master these, you need to start nicely, build up your momentum, then you can speed up, knowing that you can handle the speed. Okay, it says find the displacement after 30 seconds. Now we can already see that 30 seconds is going to push us to somewhere there. Okay, so 30 seconds is probably there. All right, icon. It's not straight. Okay, it's somewhere there. It's somewhere there. So we can already see this is going to be below the cliff. So we said up was positive. So this means it's going to be negative, isn't it? Because it's below the cliff. So we expect something negative. So we expect probably that's where the 30 seconds is. Now let's find out what is that displacement. And remember, guys, displacement is not distance. So displacement is going to be from starting position, which is essentially from the origin and then straight down. So displacement says from the start, where are we from the start? Doesn't matter what else we did. We went up and then came back and then went down. But from the start up until there, what is that? And remember, distance is positive. Okay? Or displacement is something that needs a direction to be explained. Of course, we're going to explain why it is negative, but we're not going to give a negative answer. Okay. So let's see, guys, what is that? Again, this is to say when the x value is 30, what is the corresponding y value? There. So this is just a point on the graph. So number 4 says, well, this is going to be s equals 100 into 30 minus 5 into 30 squared. You can say, therefore, s is, right, let's see, 100 into 30 minus 5 into 30 squared. Give us a 1,500, but this one is negative. But you're not going to write a negative answer. So this is 1,500 meters below the cliff. Right? because you know that if it came up negative, it means it's below the starting point, which is the cliff. So that's how you interpret that positive. You can write it as negative if you like, because displacement, in terms of sign, it means direction. So again, I would say 1 mark and then 2 marks for the answer. It depends on how the examiners feel, obviously, because you can say 2 marks, you can say 1 mark. I mean, these are very simple questions. All right, let's do the 5th question and get out of this question so that we can take some more typical exam questions. This may be an exam question, but perhaps a standard grade type. Okay, calculate the acceleration of the projectile. Okay, now, the acceleration is the change of velocity. So this means second derivative. And we know that the second derivative is a constant, because a second derivative of this function is going to be stuff like this. It passes somewhere, right? We know that when we differentiate a quadratic, we get a straight line. But this straight line is such that it will pass at the axis of symmetry, that being its x-intercept. So this would be the second derivative. And it's a constant. And this is why we're saying acceleration, because acceleration usually is a constant. We don't have an acceleration that is not constant. We normally talk of uniform acceleration here. Okay, as much as when you're driving a car, you can actually increase even on that acceleration to increase the speed further, whatever. Okay, so you can already see, guys, we need the second derivative. And then when we say the acceleration, we want the second derivative. That would be what gives us the acceleration. So we know that the acceleration acceleration is going to be the second derivative, obviously. So now, konje ibhalwa kanjani? Babhala d. Konje ibhalwa kanjani? Twa d ton for s over dt. I think so. Yeah, I forgot the notations anyway, but let's just keep going. Second derivative, we're going to differentiate the first derivative. We're going to differentiate this one further, and you can see that this tells us it's going to be minus 10. But then you're not going to write minus 10. You're just going to write 10 meters per second squared downwards, because it was a negative, isn't it? So negative in this scenario means downward. And you can see this is more like gravitational acceleration. So if you round off to the nearest, you get 10. Okay, all right, okay. So you're good, guys. You're good. You must be. If you're not good, you are not a student for mathematics. So you get 2 marks, guys, for the answer, knowing that you needed the second derivative. Of course, I'm just trying to give you a basic question where we can, where we can do the things, Now, folks, you may ask yourselves a question. What would be the velocity at 20 seconds? If I may ask. What is the velocity of this whatever? What did we call this? A flying object or a projectile? So if I may just add an extra question, say, what is the velocity of the projectile at 20 seconds? What would you say? You should be telling us. You should be telling us. You should be telling us. Those who know and do physics, they would know that the gradient at the intercepts for a parabola, well, it's just going to be the same in magnitude, but different in value, right? In that the other one is downward while the other one is upward. So you know that we were told that the initial velocity here was 100 meters per second. So this means the gradient at 0 was 100. Now we're talking gradient. So it means the gradient here should be 100, because when it comes back down, it comes back with the same velocity. So this would be 100. Now we're talking gradient, but downwards instead of upwards, because this object was moving up. In this case, it's moving down. So you can just write the answer and say this is going to be 100 meters per second downwards. Nice and easy. Right, so you get 2 marks for the answer, because this is something that says you need to know this. But for those who don't know, you can go about it the long way and say the velocity is going to be the first derivative at 20. Right, which is going to be equal to, let's see, I hate this part or this way of writing. So this is going to be 100 minus, what is that? 20 times 10, it's 200. Think so. So this is 100 minus 200. Can you see it's going to be minus? So you're going to just write the positive answer, meters per second downwards. Light, all light, okay, all light. So again, you can get your marks like that. It's up to you how you solve this problem. Fact of the matter is, get it solved. Okay guys, I wish I could stop here, because I mean, it's all about basics, isn't it? So teachers, their duty is to show you basics, and your duty as a student is to take it a notch further. Alright guys, so let's take some past exam questions and then get to business. Okay, alright, so this is it for our basics. We just wanted to highlight a few issues. Now we're going to start handling some past exam question papers. So I'm not sure which year this document was. Anyway, I don't remember. So I will share this document in the, in the description below. So we're going to be able to do this. Now I told you, a boy uses a 12-meter wire to form a circle and a square. Again, AQL. Each side of the square is X meters long. Right, now it says show that the total area of the square and the circle formed is given by this. So again, this is a very nice question, because I could easily have just said for 8 marks, determine this question right there and let you sweat. So sometimes it can give a standard grade question, but you can see that this is heavy. It's not so easy. So you need to know what to do. Right, so if you've got this 12-meter wire, right? Now we're going to split it so that we form a square and a circle. So let's see, if we decided that we're going to cut it such that this part here forms the square. So remember, you need to know these structures, guys. So you can see that this part has formed a square of X centimeter in dimension. So as you can see, the perimeter here, because this is where it came from, so we're going to use the knowledge of the perimeter to go back. So this is going to be x times x times x, not times but plus. So this is going to be x plus x plus x plus x. So this means this portion is 4x. Now if that portion is 4x, this means this remaining portion is what? Yes, if this is 4x, this is going to be 12 minus 4x. So remember that. And now from this portion comes forth a circle. Now remember, what is this? The perimeter of a circle is the circumference. Right? It is the circumference. I'm leaving it. So that's the circumference, guys. So the perimeter of a circle is the circumference. Now, what is the story here? Now remember, what do we say? We want to know the radius of this circle. We want to know what is the radius. But we know the circumference from here. So we're going to do things. So let's go for it, folks. So we know that the area A is going to be the area of a square, which is the side squared. So this is x all squared. Plus, now, for the circle, we need, because we know that this is going to be pi r squared. So maybe let's not rush for this one. Let's not rush. Let's start somewhere and say, okay, fine. We know that the circumference of a circle is going to be equal to pi d or 2 pi r. Some say that. So this is pi d, or maybe let's just say this is 2 pi r because we're interested in the radius. So we know that the circumference is 12 minus 4x. This is equal to 2 pi r. Now, if we look for the radius, we know that our radius is going to be, essentially, if we divide by 12 throughout, this is going to be 6 minus 2x all over pi. Okay, so that's what we have over there. I hope it makes sense. Now we can say then area is such that A is equal to the area of a square is a side squared plus the area of a circle is pi r squared. Now the r squared is nothing but 6 minus 2x all over pi squared. Now let's see, this is x squared plus pi into, when we square the numerator, it's a binomial, it's going to be 36 minus 6 by 2, that's minus 12 by 2, that's minus 24x. And we square the last one, is going to be plus 4x squared. Then of course we square the denominator, this is going to be pi squared. Now when we do the things, this is going to take that. Maybe let me show this better. This 2 is not looking good. Yeah, maybe let's do this. That pi takes the square. And what happens? We end up with x squared plus. Now we have, remember when you distribute the positive here, we can just say this is 4x squared, okay, then minus 24x, right? Right, and then we can say plus 36. Ne? Of course. And all of this, guys, remember, this is all over pi. We are not done. So this guy is over 1. It's a fraction. So again, what is the common denominator? Is pi times 1, which is pi. We're using the LCM. And then we cross multiply here if you like, or you can just do the other stuff and say this divided by that and then times the numerator. But all we know is that we're going to have pi x squared plus 4x squared minus 24x plus 36. So that one doesn't change. And then we can see that between these two, because they are like terms, we can factorize here by taking x squared out. So when we do that, what do we end up with? Hey, kwenzeke ntoni? Kwenzeke ntoni apha? Something happened that I don't like. Oh, akho nto yenzekile, ndiyabhayiza. Right, if we take the pi out, then, the x squared. So we just remain with pi, but now they decided to write the 4 this side. Plus pi, and then x squared is out. Then minus 24x plus 36. This is what you called factorization by grouping. Of course, we make sure that this thing is exactly the way we are shown. As you can see, this looked easy, but it's not as easy as it looks. You had to go around some situations here. Alright, so that's it, guys. To find the radius is very important. That's mark worthy. And for the area of the square and the area of the circle, that's very important. Then, of course, all the gymnastics, guys, that were necessary. First of all, to foil things here, I would say to get to this stage, it's a mark. Seems right. 1, 2, 3, 4. And then to find the common denominator, that's 5. And perhaps to know that you needed the circumference of the circle here. Maybe that would be the 6th mark, because this was already given. But we may give a mark for this as well, if we choose, because how it came about is quite technical rather than straightforward. Okay, all right, okay. Now, what is the second question? It says 1.2. We need to determine the values of x for which the total area is a minimum. Again, if you look here, the highest power is quadratic, so the constant, we don't care about it. This is a constant also, we don't really care about it much. So all we know is that when we take the derivative here, we literally are going to take the derivative of the numerator. The denominator is a constant, so we don't worry about it. Yes, you may want to, divide by that, but it doesn't make any difference, is it? Remember, we've got what we call a constant multiple. Maybe we can talk about constant division. Yeah, so we can make this a constant multiple. We can just say, well, area A, we can just convert this to a constant multiple. Remember, we are smart people. We know that A is going to be 1 over pi. We make this a multiple to this. So we've got 4 plus pi x squared minus 24x plus 36. So it helps, guys, to know how to write expressions, because sometimes you may be thinking, hey, now as you saw the rules that I showed you, as much as they don't teach you this constant multiple thingy, now you know, because I taught you. So you cannot tell me things. And you can see this is a smiling parabola because this can never be negative. So the coefficient of the highest exponent, highest power there, is going to be positive. So it's a smiling face. As a result, it makes sense to say minimum. So we can say here, for minimum, area, it is such that dA over dx must be equal to 0, isn't it? Yes. So let's differentiate. Now we know that the constant is such that we just leave the constant out, and then the constant is going to stay there by using the constant multiple rule, and then we differentiate that expression. So this is going to be 2 into 4 plus pi. Then this is going to be x minus 24. The constant goes away and we equate this to 0. Now do you realize that we're going to have to divide by this constant and it literally disappears? Ah, you saw it, you saw it, you saw it. So we continue, guys. So we will see that we've got 8 when we FOIL this. All right. So when we FOIL there, it's going to be 8 plus 2 pi. And of course, we want to leave the x out. And then this is going to be equal to 24. And if you liked, you could easily divide by 2 and then divide. In fact, let's not be crazy here. Let's not waste time. Sometimes, guys, choose the best approach that answers the questions without wasting time. In the exam, time efficiency is important. So we can easily just say, well, 2 into 4 plus pi x is going to be equal to 24. So we can therefore say x is equal to, now we put it on the calculator and just say 24 divided by 2 into 4 plus pi. Right? Right. That's just what we're going to do. And then this gives us a nice answer. Of course, we're not told to what minimum decimal place is. We can assume 2. So x is basically 1,68. And we were told this is meters, so this is going to be meters. All right, folks, so this one was easy, but technical. Now, if you know the rules that I showed you, you will not struggle to solve these problems. As you can see, if you don't know these constant multiple rules, you will always get around these points and cry. Like, yo, what am I gonna do? Even not knowing how to simplify expressions so that you can see what to do. You're gonna be like, yo, what am I gonna do? You're gonna do what you're gonna do, right? Yeah. So basically, for all of that, we get a mark, and for the value. So for differentiating and equating to 0 and then solving, making sure that you don't forget the meters. And of course, the general instructions here are to take precedence. All right, so that was easy. As you can see, guys, there's nothing with this optimization thing. It's just a matter of knowing word problems. As you can see how we broke it down, this is your rough work. You don't have to show this. All of this is rough work so that you know what to do, because the intention is so that you can know what to do. Okay, it doesn't come up nicely, so this is all RW. We don't need to see that. It's you breaking a question down enough to be able to solve it. Right. Next question. Okay, this question says a farmer has a piece of land in the shape of a right-angled triangle OMN. Nice. As shown in the diagram below. So you can see this OMN. Okay. Hence, he allocates a rectangular piece, pito, to his daughter, giving her the freedom to choose P anywhere along the boundary MN. And we are told to let OM be equal to A units and ON B units. And of course, P axis to Y. It could be any point on the Cartesian plane along MN. Okay. Now the first question says determine the equation of MN in terms of A and B. Okay. This is very easy, guys. I mean, these are also leading questions. In the NBTs, you will not be queued. You will be just shot to this question straight up. Okay, so let's do this one. We know that this is a straight line equation. B is the y-intercept. The gradient is going to be negative, change in y over x. So it's going to be minus b over a x. Right? So here we can just do it by inspection and just easily say, we know that mn is going to be equal to minus b over a x plus b. That's as simple as that. In fact, we can say y so that it looks easy. So we know that mn is such that y is like so. But of course, for those of you who prefer to struggle, you can use those points and say, you're going to say the gradient of mn is going to be y at n minus y at m over x at n minus x at m. So y at n is b minus y at m is 0 divided by x at n, that's 0, minus x at m, that's a. And all you have here is going to be minus b over a. So you can choose to struggle and then write the equation. Therefore, y is going to be minus b over a x plus b, because that's the y-intercept. So this is how you would want to go about it, the long route. Or you can just look by inspection and kick it. Kick it. Do not waste time. So I would give 2 marks for the final answer. If you chose this route, 1 mark for the gradient and for putting it together. Nice and easy. So 2.2 says, prove that the daughter's land will have a maximum area if she chooses P at the midpoint of MN. Now, a midpoint of a line, guys, you know that the x value is going to be the average between the two. So it's going to be a divided by 2. So it means we need to prove that the x-coordinated p is a over 2, as well as b, we're going to just have it, isn't it? So this is to say prove that at maximum area of this rectangular piece, we will achieve this when P, the coordinates of P are A over 2 and B over 2. So you always interpret what the statement says so that you don't struggle to figure out. Can you see the midpoint is analytical geometry in here, if you look at it? But it's coming up here. And here you're at liberty again. If this is a rectangle, we know that this side is parallel to this side. You can also use proportionality of similar triangles. You know, these things are very interesting, man. They will just help. Okay, let's start with analytical means, let's say, or analytical method. So guys, what is this height? Right. So I'm just trying to think. If you look at it, the y value here is exactly the equation that we got. Y here is going to be equal to minus b over a x plus whatever. So as you can see, for any x value that we see there, that's exactly the y value. X is x and y is y. So what does this mean, guys? So this means this height is going to be nothing but minus b over ax plus b. So that's the y value. And then that's this dimension here, which is the length, is nothing but x. Whatever x is at p, that is going to be x units. Now we have an expression for our rectangle, because now we need the area of the rectangle. Then after that we maximize it. So we can just say area of rectangle. What was it called? Pito. Right? It's going to be length times breadth. So this is going to be OR multiplied by ORP. Okay, so let's get to business. So we can say this implies that we can call it A in terms of X, right? Or whatever. Let's just call it A. A is going to be equal to OR is X into minus B over A X plus B. Isn't it? We can say therefore A is minus B over A x squared plus bx. As you can see, an area will always come up as a quadratic equation. So now we've got a quadratic equation. So what do we need? For maximum, we are going to differentiate. For maximum, it is such that for maximum area, not just maximum, area is such that dA over dx is equal to 0, isn't it? So let's differentiate. We multiply this by 2, so it's going to be minus 2b over a x plus b equal to 0. Right. So this implies we want to solve for x, isn't it? So this implies that minus 2b over a x is going to be equal to essentially minus b. Now we divide, so let's just move on, guys. So that means x is going to be, therefore this is going to be as good as this b over 1 multiplied by this one flipped. It's going to be a over 2b. And as you can see, that one goes, and we can see that x is going to be a over 2. Kitching, that's exactly what we wanted to prove. And maybe let's just say this implies, to avoid a quick conclusion, we can also say therefore y is going to be, we substitute this where? Back into the area equation, isn't it? Yeah, that's exactly, not the area, but here, this is the equation. We want to solve for y. So this is what helps us to solve for y. So we're going to have minus b over a. X is a over 2 plus b. Now we can already appreciate, guys, what's going to happen. A will take a. And then we've got minus b over 2. So this is minus a half of b plus 1b. The answer is going to be the half of b. Okay, chain. So at this point, you can say, therefore, the daughter will have will have a maximum area if P is chosen as the midpoint of MN. So you can make the conclusion, you can say, therefore, the daughter will have a maximum area at midpoint of MN. Okay, whatever, guys. Say what you will, and it's done. I'm just trying to not have to write it on the next page. So that's exactly what you do, folks. Easy peasy, lemon squeezy. But these are higher grade questions. As you can see, they came from the past, but they are now being asked in the present. So hey, look into the past sometimes. You will be surprised where you are going to go. All right, okay, all right. 6 marks. How do we get it? Getting the area, then the derivative and equating it to 0. 3 marks. The value of A, the value of B. Sorry, the value of Y, because remember, this X is the X value at P. You can even indicate here that therefore the X at P and therefore the Y at P, because those are the ones that we're looking for. Right, so 1, 2, 3, 4, 5. So where is the 6th mark? Can say any of the substitutions, folks. Whether this or this. So any of the substitutions, we give an extra mark. I'm just going to write it in space. It's for any of the substitutions. Okay. See? Not a big deal. Do you want to use similarity perhaps to prove it? To proved? Do you want to use similarity to proved that this would be the situation? Okay, I'm thinking. May not be so friendly, is it? It may not be very friendly. Now, let's not complicate it. We don't have time to play. Okay, let's look at this one from the northwest. So question 3 says, in the sketch below, triangle ABC is an equilateral triangle. So what do you know about equilateral? It means this side is equal to that side and equal to this side. Right? Very much important. So ziyalingana. Now I'm just gonna indicate it. You know, I don't know, you can say this side is equal to that side as a whole. Now in an equilateral triangle, we know that the angles are 60 degrees. And they are all equal. I'm just gonna show it like that. Can you see? All Euclidean geometry information is important. AB is m units. So that means AC is also m units as well as BC. Now we're told DEGF is a rectangle. So now a rectangle, we know that these opposite sides, okay, maybe let's use a different notation. We know that the opposite sides are equal and parallel to each other. And then we can say V sort of, these ones are equal and parallel. It's a parallelogram, but the corner angles are 90 degrees. Okay. Very important to know. So this is the breakdown, guys. So don't rush when you do this. It tells us now that BF is equal to GC equal to X units. So this is X. And this one is also X. Right. So the first question you want to ask yourselves is what would be the length of the side of this? Now on the horizontal, because I don't have space, I chose to write it up there. We know that that side is M, right, minus the 2x. So this is going to be M minus 2x. Because this would be equal to this side. But this side is part of BC. BC is M. If we take away x and take away x, we remain with that side. And of course, we said the opposite sides of a rectangle are equal and parallel. So that's a skill, guys, to know how to do this. It's a skill. Next, what about the height? What about the height? Do we have a way of showing the height in terms of either x or m? What are we gonna do? What are we gonna do? Okay, now let's think about it, because this is very important, because I can see that we've got an area there. There's a square root 3 and all that, whatever. But I see x, m, and the root 3. So this already tells us that we're going to use trigonometry here. So if we look at this triangle, if we look at that triangle, we'll appreciate that this is a right-angled triangle from the properties of a rectangle. Because if one angle is 90 degrees, then from angles on a straight line, we will be able to prove that that angle inside is also 90 degrees. I don't need to show it. Now I can use trig ratios because I'm looking for the opposite side. So the opposite side is going to be, but of course I don't want BD because I don't know the length of BD. So I'm going to use the tangent here, because the tangent is going to be opposite over adjacent. So this is going to be good. So this means from here we know that tan 60 degrees is going to be the opposite, which is DF, over the adjacent, which is BF. Right, what is tan of 60, guys? You know that it's root 3 over 1, if you will. So this is going to be DF over BF, which is x. Therefore, DF is going to be root 3x. Can you see? So you already work out things. Can you see trigonometry kicked in here? And Euclidean geometry stuff also kicked in. And of course, some logical stuff here had to kick in. So 3.1. We need to show that the area of a rectangle is like that. So what are we going to say? Easy. We're going to say, first of all, we know that BF, let's just be careless a bit now, plus FG plus GC is equal to M. Right? We can say ABC is an equilateral triangle. So this one is shown like that. Let me show it a bit better. Is an equilateral triangle. So we know that all sides are equal. So this implies that X plus FG plus X is equal to M. Therefore, we know that FG is going to be equal to M minus 2X. We just want to show how we calculated things. Remember, we have to prove. Now, a proof will show everything. It's like calculate. You cannot just do whatever you want. So that's first, the most important thing. The second thing we can say also, in triangle BDF. Okay? What are we going to say? Well, we know that that is a right-angled triangle. At this point, we don't want to explain too much, guys. We're just going to say, well, sine, not sine, but tan of angle B is going to be DF, the opposite side, over the adjacent side. Right, so what is the angles in an equilateral triangle? 60 degrees. You needed to know this. Then DF is what we're trying to get in terms of X and M, of course, if possible. So this one is going to be BF, which is X. Now from special angles, we know that tan 60 is root 3 equals DF over X. Cross multiply, we know that DF is going to be root 3 X, okay? As you can see, it's not so easy. Yes, it looks easy from the 3 marks, but not so easy in terms of the operation because we need to see everything. We can say then area of DEGF is going to be equal to length times breadth. So the length is FG was it? You can just say FG multiplied by the breadth, which is DF. And we just go on. FG is basically M minus 2X times root 3X. And we solve this. Actually, this is good. So we can just do, so most multiplication is commutative. So we can write root 3x in front into M minus 2x. It's done. Again, you see properties of whole numbers, commutative versus, all those things, associative, and you name those things. So sometimes these questions are asking for these. Do you know that it is possible to do so? Okay. All right. Okay. So this is cool. We've sorted it. Can you see quite a lot of work, almost filling the entire page for just 3 marks? Obviously, we get a mark here, guys. Ne? Yeah. We get a mark there. And we get a mark here. And we can say the substitutions into length times breadth and whatever. And everything is as easy as it looks. Okay, it's your problem, of course. Now let's see, 3.2 says, determine in terms of M, the maximum area of the rectangle. So in terms of M, obviously, they didn't have to say this, but they could just easily say determine the maximum area of the rectangle. But you would see that you can't get rid of M here. Anyway, it's as simple as that. We know that for maximum area, we know that we're going to say dA, let's call it A. So we can say dA over dx, because we always differentiate like that, must be equal to 0. So this tells us that now when we have to do this, we need to get rid of the brackets, isn't it? So in your mind, I mean, the product rule still holds, but let's not complicate our lives. Maybe let's start by sorting it up before we differentiate. So we know that area is going to be equal to root 3x into m minus 2x. And we can say, therefore, a is going to be root 3 mx minus 2 root 3 x squared. As we said, area will always be a quadratic equation. So after doing what we needed to do, you can say for maximum area, this is what we know. Okay, so let's differentiate. So this is just going to be root 3 m minus 4 root 3 x equal to 0. So we know that this implies that minus 4 root 3x is equal to minus root 3m. Okay, all right, okay. So what is the value of x? X is going to be, okay, let's not rush. Sometimes when the equation gets a bit complex, take it easy so that you don't make mistakes. Divided by minus 4 root 3. So we know that this and that will go. The negative and the negative goes. So we know that x is going to be m over 4. Okay. I can say then maximum area, right? Why are we even talking maximum? Because look at our quadratic. The coefficient of the highest power is negative. So that's a grumpy face parabola. It will have a maximum at the turning point. So always think about these things. Is equal to. We go back to the area equation. So this was root 3. Now where you see x, we're going to put m over 4. Right? Into m minus 2. Maybe let's put a square bracket here. M minus 2 into m over 4. Okay, we can say therefore the area here is going to be, now this is basically so let's think about it systematically. Let's not rush. We just need to simplify up until we can't. Okay, let's start by Let's start by sorting the brackets inside. So we have root 3 m over 4, right? We break these ones, it's going to be m minus m over 2, okay? So we can now make up our minds and say a is going to be, multiply there, it's going to be root 3 m squared over 4 minus, multiply there, it's going to be root 3 m squared over 8. Now we can see we can still simplify this thing. These are like terms. So we simplify up until we can't, guys. You don't stop before you get to the end. So this is over 8. And we cross multiply these things. If you want, but I would rather we don't do that. It's much easier if we say 8 divided by 4, this is 2. So we're going to have 2 root 3 m squared minus just root 3 m squared. Therefore the area, now 2 root 3 m squared minus root 3 is nothing but root 3 m squared over 8. Now that is perfect. So you simplify, folks, up until you can't. Don't stop until you have finished. I don't know what happens if you decided to leave it here. But anyway, this whole thing is the same as this thing. So whatever. Guys, I'm feeling dizzy now. Why so soon? I actually wanted to move, man. 4 marks. Substitution. Yeah. That's a mark. The derivative and equating to 0. Yeah. And the final answer, whichever you decided. I'm sure you can see, guys, you've got options. You can leave it there. And you can also leave it there. But I think it's only fair to to simplify until you cannot. So that's the easy 4 marks, guys. And we have our 7 marks. As you can see, if you're in the Northwest or Gauteng, expect stones, okay? They throw stones at you. But if you're in the other provinces, you can practice normal maths, but in fact, just get used to everything. All right, so now let us get to this question from Gauteng. The reason why I'm taking these questions, guys, is to show you what to expect in your next exam, because these are not so far away exams. They were written recently, 2021 or so. Now the profit W as a function of X is earned by a company to manufacture X bicycles per week. Is it bicycles or is it bicycles? We normally say bicycles. Right. Given by this business here, it says now what should be the weekly production to maximize profit? What should the weekly production be to maximize profits? Now the nice thing is you are given the question. All you have to do is to do what needs to be done, okay? That's all. But now the doing of the needing to be done things is going to be the things that cause problems for you. Okay, because it's going to be a bit painful. But this is very easy. We know that W, so basically the question says solve for X because that's the production per week. But we're going to start by maximizing the profit. So let's write it down. So this is minus X cubed all divided by 150 plus 3X squared minus 250X minus 2,700. You can see this is a cubic function of this shape. So if we're talking about maximum, we're looking for this X value. What is it for this maximum turning point? Okay. So always have in mind what is being asked. As you can see, this is again applying functions instead of measurement. But you saw that everything boils down to a function that can be differentiated. Yeah, you should remember that. All right, okay, all right. So we are expecting two X values, but one that is ahead, not the one that is before. Okay, so we know that for maximum profits, or profit, let's say, it is such that we're going to say W prime of X must be 0, right? So use the function notation when stuff is given in the function notation. Now we go and do it, guys. We multiply by 3, so this is going to be minus. Now how many times does 3 go to 150? By 50, ne? Yes, so this is going to be X squared over 50. Then plus. This one is going to be 6X minus 250, right? The constant is not here. Okay, all right, okay. Now we need to solve this quadratic by multiplying by minus 50 throughout. So minus 50, so that we don't have a situation of that negative. So when this happens, we're going to get X squared minus 6 times 50. Come on. It's 300, but now this 300 is going to be negative. Right, 250 times 50. This one is going to be positive. Right, let's see, 250 times 50. You should also know how to do this without a calculator, né? 12,500. Here. Now you've got a nice quadratic, isn't it? Is it factorizable? This is me being ambitious. Most likely not. Let's check the discriminant if it is a perfect square. So b squared is going to be minus 300 squared minus 4 into a, which is 1 in this case. C is 12,500. Let's see. This gives us 40,000. Now the square root of that is 200. So it's a perfect square. So this means it can be factorized. Right. So we're going to have here x. Okay, let's see now. What are the factors of 12,500? I'm already thinking it's 250 and 50. Actually, these are the ones. Because this value came from this multiple. And I can already see that 250 and 50 are essentially going to give me 12,500. So this is going to be 250 and 50. As you can see, the addition of these two is going to give us 300. Minus 300. So this one was much nicer. But of course, if you panic, you can use the calculator, use the quadratic formula. You would be fine. So now, folks, you see we have a problem. We've got two values. So which one is going to give us a maximum between these two? You know that the smaller value is going to give us a minimum. So this means this is going to be the 50. But the 250 is definitely going to give us the maximum. So here we know that x must be equal to 250 bicycles or bicycles per week. Ngeveki. Yeah. A nice question if you ask me. Now, ndiyazibuza ke ngoku. Kutheni uyi-8 marks? Ngoba incinci le nto man. Ayikho ninzi man. Siqhela kabi qha. I mean 8 marks le nto le. Sanuzodlala nina. Nigqwere kudlara nina. Nizokudlara rana. But hey, it's a tricky thing after all. So maybe you're getting a mark for equating this to 0. And then the examiner is probably giving you a mark for each of the derivatives, because now I don't find any sense in saying 8 marks here if that's not the case. And I believe it should be the case. Normally we just mark the whole thing once. But of course, guys, hey, what can you do? Then I can say, well, you get another mark for this, for factorization, and choosing the right answer. So 1, 2, 3, 4, 5, 6, 7. Where is the 8? I guess we can say 2 marks for the answer, guys, for knowing what to choose. At the end of the day, if you've done the right thing, you don't have to worry about where the marks are. If the answer is good, the procedure is right. Can you see sometimes this thing, you need to think about it, eh? Think, so that you know which value to choose. Otherwise, if you don't know the shape of your function, you won't know which value is going to give a maximum. And you will end up choosing the wrong value or being unable to choose. So yeah, this was not a difficult question, but a rather nice question. Now let's look at the Vrystaat. What are they doing there? Question 5. So question 5 says that the diagram shows the straight line h, where h of x is the first derivative of f. Okay, so this straight line is the first derivative, and as you can see, it's a straight line. So this means the parent is a parabola, right? Right. But if this first derivative is positively sloped like this, it means my original graph is most likely stuff like this. And in such a way that my turning point is exactly below 1. However this is going to be. So I know this is what probably is my parabola. Of course, it could be one that has no real roots or one that has real roots, whatever. So it can be anywhere. But I would just assume it has real roots. Now let's have a look. We are told that the x-intercept of h is 1. We know that that would be the axis of symmetry for the original. It says now the following is true for function f. F of 1 is -3. Okay? Right. And then f of 3 is 0. So this means this is 3. And f of 1 is over here maybe. Sorry. Now f of 1 is this one, the axis of symmetry, right? Okay, forget about that. It's not really symmetrical, but yeah, that's the impression I'm trying to create. So this tells us that the y value at the turning point is -3. So someone is giving us the coordinates of the turning point, that this is 1 and minus 3. So can you see, guys, knowledge of functions? Now when you think calculus, it becomes so nice. You see what, when you overlay that function, now we know that there's no way for such a function not to have, two unequal roots. Most likely it's going to be as we drew it. As much as we were guessing it, but it came out nice. It says now draw a sketch graph of the function f, clearly indicating all intercepts and the turning point. Now, of course, guys, by using symmetry, we know that the distance from the axis of symmetry to that turning point is going to be exactly the same distance from the axis of symmetry to the other turning point. So now we saw that from 1 to 3, we moved 2 units to the right. So this means we're going to move 2 units to the left. So 1 minus 2 lands us at minus 1. So we know that, yay, we didn't guess too much. We guessed just right. So you work on these things on the function or on your rough work. Then you do the things. So this was 5.1. We need to draw the sketch. Can you see? Given information, we need to draw the sketch. Now there we have it, guys. So with calculus, it's going to just be fun and games. As you can see, calculus simplifies even the knowledge of functions if you appreciate its beauty. But if you don't, obviously you're going to cry and say, this thing is not nice. So this is our function f, guys. And we saw that this is 3. And the coordinates of the turning point, I go straight. Mayibe straight. Ingajijeki okanye ilale ngecala. Alele ngecala, it's slanting or diagonal. Can you see? Nobody asked you how to find them. They just say, show us. So, mna-ke guys, ngithanda ukwenza kanje mandenze graph. I don't like to write the coordinates like this. It makes the graph look scary. But if you don't trust this technique, do it your other way. It's not a big deal. So, the parabola is complete, guys. So, you get a mark for the shape. How did I know the parabola is going to look like this? Yes, sometimes the information given, if the turning point is like that and the intercept is like that, there's no way that this graph is going to be concave down, because if it is concave down, it means, it won't reach the axis. So it's already giving you everything you need. But, I knew it from this guy. If you look at the first derivative function, if that m, the gradient of the first derivative function, is greater than 0, then you know that the original function is a parabola with an a greater than 0. So these things are interlinked. And if that's the case, I know I'm expecting a smiling parabola. You know this. So knowledge of functions, guys, a deep understanding is very much important, comrades. If you don't have it, you're gonna die a slow death and think maths is difficult when it's actually very easy and fun. Okay, during an experiment, so it's a different question. They like these kinds of questions. Please have a look at them. These are higher grade questions. We used to have a lot of these, okay, also. So enjoy these kinds where you're given parameters of something and you have to work back using your knowledge of functions. Now it says, during an experiment, the temperature T in degrees Celsius varies with time in seconds. Now again, you see, we are modeled here a situation of a cubic function. But look at this, there's a restriction. this is a restricted cubic graph. It's not like the normal one. So there's going to be problems if you're not careful. So 5.2.1. Here we knew that temperature as a function of time is going to be 60 plus 27t minus t cubed. So it's a cubic function of what shape again? Even though we don't care what it looks like exactly, but we know that the shape is of this form. Right, so bear this in mind, because when you optimize, if we say maximum, then it means we are looking for this one. Okay, we're not going to take the one before this. So the biggest t value when we differentiate is the one that we're looking for. Okay, so always bear this in mind, guys. Don't forget, this is your memory. Let's ka sokola mona ka baka la hore memory wa lona o shwele. Memory wa lona o tshwanetse o sebetsa bana beso. Now this one is very clear. Calculate. So you cannot do other things here. You have to do the right things. Now it says calculate the average change of temperature between 3 and 6 seconds. So change the average change of temperature between 3 and 6 seconds. So what do you guys think needs to happen here? You must sit back and think about it. You're probably shouting, seated at home there, that, hey, I know it. Once you say average gradient, guys, it means we just need to substitute 3 into the original and find the corresponding y value, and we substitute 6 into the original and then get the corresponding y value, and then we do the average gradient. So this one is very easy. Unfortunately for this one, you are not at liberty to differentiate as yet. But you can still use the derivative equation, but without the limit. Okay? Without the limit being 0. So, for me, I can just do the function notation here. Because I see 3 marks, I don't need to waste time. So I can just say here the average gradient, or we can just say M average, is going to be T at, say, 6 seconds ahead minus T at 3 seconds divided by the difference in the x values. So it's going to be 6 minus 3. It's as simple as this, guys. No need to stress here. So this implies that the M average, now we've got 60 plus 27 into 6 minus 6 cubed minus, right, so we've got 60 again, plus 27 into 3, right, minus 3 cubed. Aibo. Hey, yan kayan. Okay, all of that, guys, is divided by basically 3 when we solve, but we can just leave it like that and then put it on the calculator. So the average gradient, as I said, you can either choose to first find the corresponding temperatures by substituting 6 and 3 into the original. Then you subtract the y values, which is the temperatures, and as well as that to get the average gradient. So that would be the average change in temperature. Okay, so let's go for it, folks. So I've got 60 plus 27 into 6 minus into 6 cubed. Then we subtract 60 plus 27 into 3 minus into 3 cubed. Right. Close this. This is going to be 6 minus 3. Right. The answer is minus 36. So that would be the gradient. So this is already telling you and I that, well, this is going to be a negative gradient. Okay. All right. Okay. Okay. All right. Okay. So that's it. So it's a negative gradient. Now we get 3 marks for this. So how are we going to get it? Yamos. You know mos. This was a calculation. Don't know why. So this is a mark. Okay, guys. And the final answer. Those were calculations. Or you can say 1 mark for each of the calculations, the substitutions, and the answer. Up to you. As long as it's done. 5.2.2 says after how many seconds will the temperature be a maximum? Okay, now obviously guys, this tells you that this turning point right here is what we are looking for. So we want that T obviously for that last one. So we just take the derivative, right, and we equate it to 0 because it gives us the gradient, and we look for the bigger value of T that we get. So we can say, well, for the maximum temperature, it is such that T prime of T must be equal to 0. Right, so let's differentiate that expression. The constant goes away, so we get 27 minus 3t squared is equal to 0. Move the stuff around, so we know that 3t squared is going to be 27. Right, so we know that this implies that t squared is going to be equal to 9. Therefore, t is going to be plus or minus 3. Therefore, in fact, let's say implies. Therefore, t is going to be equal to 3 seconds. So this tells us that indeed we're looking at our graph there at 3 seconds because the minus 3 would have been here. And then this one is at 3 seconds. So the one that gives us a maximum is that. So that is the answer, guys. It's not a difficult question, but it needs understanding. So of course, equating the derivative and taking it and choosing the correct answer. We are happy. So that was it. Nothing really complicated here. So as I said, I was just talking about you get a mark for the shape, you get a mark for the intercept, you get a mark for the turning point. Okay, that one was the one. Now let's look at the Eastern Cape one so that you guys can fully appreciate these questions. After this, I'm going to select a few higher grade questions and we stop this video before it gets too long. So I'm targeting 3 hours some change. I don't want to go beyond 3 hours, otherwise it's going to be boring. Okay, the wooden box in the diagram is a rectangular prism, and it is open at the top. Okay, so the top is open. So if we ever have to do surface area here, we are not going to consider this. Okay, the top. Okay, then the dimensions of the base are 3x meters, so it's indicated, times by x, which is also indicated, and the height is y meters. Okay, fine. Then the total surface area is given, so thank God we don't have to worry about the top being open. Now the question says, show that y is this value. Again, I could easily just ask the 7-mark question without the first question. It is your job, students, to realize that you have to find something in between. In the NBTs, they don't ask you the first question, they ask you the last. So these questions, guys, are in a way a preparation even for those NBTs. So don't forget. Okay, so let's get to business. 6.1, we know that the area, the total surface area here, what is it? Unfortunately, I thought we were going to escape that, but we can't. So remember, it's going to be the area of base, right? Then it's going to be the area of this side and the area of that side, right? And let's see, it's the area of the base. Okay, it's going to be the area of the base. Then let's say this side as well, meaning this one. Okay, the area of this side, and then it corresponds with the area of the other side. So times 2. Right. Yeah. So let's remove this one here. And then we can say this side from the other way, and then it will correspond with that. So we've got 2 by 2 and 1. Thank you. So what are we going to do, guys? It's going to be length times breadth times 2. So this is going to be 2 times 3x times x. Right, area of the base. But now we can't multiply it by 2. There's only one of it. Then plus, or maybe let's start, yeah, whatever. This one is going to be plus. Now the area of this side is going to be 3x times y. So this is going to be 2 because there's 2 of them. 2 times 3x times y. Plus, so we're covering this side and that side. And there's going to be that side, which is going to be x and y. So this is going to be 2 times x times y. So this is for these two. And this is going to be equal to 147. Now let's simplify. We get 3x squared plus 6xy plus 2xy is equal to 147. Now we move things around, so we know these are like terms. We're going to get 8xy is equal to 147 minus 3x squared. And then we want to isolate y, so we divide by 8x. So we divide by 8x. So we see that y is going to be 147 over 8 x minus 3x over 8. Right. So we know that 8x will divide 8 as well as 8x. So that's the common denominator. So you can make a conclusion that y is going to be this. 8x, and now what do? Yes, we know that we just simply cross multiply, but we then solve. But the nice thing, you can just say 8x divided by 8x is 1. 1 times the numerator is 147 minus 8x divided by 8. The 8 goes, then x multiplies 3x, we get 3x squared. It is done. It is dusted. Okay, guys. So you can see the trial papers are going to tax you a bit. If you don't know what you're doing, you're going to be in trouble. Okay, so folks, I can give you a mark for this. And for all the gymnastics boiling up to the same answer, I mean, it was taxing. So whatever you did, it's rewarded. 6.2 says calculate the value of x for which the volume of the box is a maximum. So first of all, we need the volume. We can say volume in terms of x is going to be, volume is the area of base. So the area of base is 3x squared multiplied by the perpendicular height, which is y. Now y is 147 minus 3x squared over 8x. Right, so that's what we need to do here. Okay, so we're multiplying this. So the first thing that happens is that this x will take the square, and then we FOIL the remaining. So how are we going to do this? We can say therefore the volume of this is going to be 147 by 3. Okay, we need our calculator. 147 times 3, this is 441. Then this is going to be x minus 9x cubed. As you said, the volume must be a cubic function. If it doesn't become a cubic function, we have problems. Okay, so obviously, guys, this is all over 8, but we can see 441 divided by 8, what is it? Okay, it gives us numbers we don't like, but of course we can just leave the 8 over here. Nothing is a big deal. Okay, so that's cool. Then we can even showcase it and say v of x is going to be 1 over 8, right, into 441x minus 9x cubed. You see the technique I showed you guys already, and I'm glad I gave you a nice introduction to this topic using the rules of differentiation. So we can say for maximum area, volume, what must we do? We know that v prime x must be equal to 0. Now using our constant multiple rule, we know that this is going to be the constant into, we take the derivative, 441 minus 27x squared is equal to 0. Now we divide by 0, that goes away. So we end up with 27x squared is equal to 441. This implies that x squared is, let's see, 441 divided by 27. It gives us 49 over 3. Okay. So let's see, x is going to be equal to plus or minus, but now I'm not going to waste time. Just going to take the positive answer and leave it there. So this is going to be 4,04. What were we told? Meters. Nice and easy. Remember, this would have been plus or minus this value, since that was a square. And we know that the shape of our cubic from here, if you remember, once the coefficient of the highest power, x cubed, is negative, this cubic is like that. So we are looking for this x value. This one, the negative version, we are not interested in it. So always think functions whenever you do optimization, because no matter what topic you are at, you are going to model an equation that's going to be a function. Okay, it's either quadratic or cubic or linear. Excuse me. So guys, this is done. I think we're doing well. Is there any more? Yeah, there's a KZN question which ends it all. So let's finish all these so that you guys can enjoy the knowledge flowing. So we're getting how many marks here? 5. So obviously, guys, we get this one. Yeah. Differentiating, equating that to 0. And then solving for x. So 1, 2, 3, 4. Well, can say here for substitutions or whatever you want to look at and say and do. All right, so we are done with that Eastern Cape. You can see it was not so bad, but you could easily fluff it if you don't know what you're doing. Now let's look at the KZN question. Question 7. It says a matchbox consists of an outer cover, yeah, open at both ends. We know it, this one, right? Into which slides a rectangular box without a top, which is this one, and it's essentially that one, right? Without a top. Okay, cool. Now the length of the box is 1.5 times its breadth. Okay, the length of the box is 1.5 times its breadth. Interesting stuff. Again, AQL here, it needs to be here. The thickness of the material is negligible. In grade 10, you will see that thickness sometimes is considered. And remember, those higher grade questions in grade 10 of measurement will haunt you in grade 12 if you don't know them. And I've seen some very crazy higher grade questions on measurement in grade 10. So don't underestimate grade 10. Just because it's a grade before matric, the level is even stronger than in matric, if you ask me. Because at grade 10 level, you're usually not as matured as you are in grade 12, but already we are asking for some maturity. Anyway, the volume of the box is 25 centimeter cubed. Now, folks, we have a problem. When rinale butata, right? But butata barona was simple, simple. Because when we say box, the question is what box? But now the nice thing is that there is a demonstration here. As you can see, the length of the box, whatever this is, the box meaning its components, can you see this is 1.5 times its length. And we can see that the same dimensions are here because we said the thickness of the material is negligible. So this is to suggest that whatever is the case here is also the case for the small little box. So this means for the entire thing as a whole. Okay. So always look at what is given, guys, and make sure you're not making a mistake. You're not making a mistake. Haibo. If the breadth, is it the breadth? The breadth. If the breadth is x centimeters, which is already indicated, right? Write down the height of the box in terms of x. Okay. It's not a problem. So we're going to have to use the volume because we've got it. So easy. So now a question that says write down, it means answer only, guys. Because whatever you write down first, if it is wrong, it's going to be marked. So don't do manga business here, but I'm going to show you. So in any case, the volume is area of base multiplied by the perpendicular height. So the area of base is going to be x times 1,5. So we know that volume in terms of x, right, it's going to be equal to, okay, let's just say volume. Let's not complicate lives. We know that volume is going to be the area of base. So this is going to be x times 1,5x times the perpendicular height, which is h. Now, this implies that 2,5 is going to be basically 1,5x squared h. Therefore, h is going to be 25 divided by 1,5. Anyway, times x squared. All right, so that is the answer, guys. I don't need to simplify any further. Maybe we can. Let's check. 25. I went high, superb. 25 divided by 1,5 banlo. Okay, yeah, it's not worth it. Let's leave it as it is. Okay, all right, okay. So of course, guys, this is your answer, and I would rather you present the answer only. For questions like this, avoid trouble. You get 2 marks, and let this one be your rough work elsewhere. Because if you end up writing this incorrectly, and maybe somehow you end up with the right answer, remember the first thing you wrote will be considered. Now, if those things don't tie up nicely, then you end up losing easy marks, okay? Don't allow yourself that misfortune. So 7.2 says, show that the amount of material used for the box is given by, yes. So this is now a very interesting part where, again, it's just 2 marks. Anyway, so this conditions. Right. Now, once we talk of material, guys, you know that we're going to talk about surface area. So just know that anytime with measurement, in this case, once you hear the word material used, it means area. Okay, just remember that. Capacity means volume. Now, massive, total surface area of this box. Now remember, we're going to consider this box closed like this with everything there. So it's going to be area of this side, which is repeated on that side. Area of this side, which is repeated on that side. And then the base or the top, whatever, which is also repeated at the bottom. So that's exactly what we are going to do. So we know that, well, the area, total surface area, is going to be that of the base times 2. So this is 2 times x times 1,5x, okay? Plus, we look at the one side, this is going to be 2 times x times the height. Now the height is what we see there is 25 over 1,5x squared. Now that would be that area, considering that side, and then we look at the last one. So this is plus, again, 2 times the area of this long side. So the long side is basically 1,5x times that height as well, which is 25 over 1,2. Did I say 1,2? No. 1,5x squared. Okay, we'll just simplify now. So this implies that A is, so this is basically 3. 2 times 1,5 is 3x squared plus, now we sort that out, so the square will take the x, and we have 2 times 25, this is 50 over 1,5x plus, then here everything goes, okay, not everything, this one takes the square, and the 1,5 goes, so we end up with 25 times 2, that's 50 again, over x. All right, okay, all right. So this is over 1. So we know that we sometimes need to sort things out. Kutheni singekho square nje apha? Ndibona khona izisquares endingaziqondi ngoku. Did we do everything? Nathi siyigqibile nje. Kutheni ngosekhona 4,5x squared? Hayi, angisazi. Akisayitsi. Now bafethu, we have to do the things, right? Yes, we have to do the things. I'm feeling like this is punishment, but yes, so born. We shall see. Okay, area is going to be, the common denominator here is going to be 1,5x. All of those numbers will go into it. So this one divided by that is itself, we multiply by that. Hey. This is our board. So this is going to be 1,5 times 3. Hi, what is ophuma, son? Can't you panic for no reason? That's the 4,5. So this is 4,5x cubed, okay? Plus, this one 1,5x and 1,5x goes, so it leaves us the 50. Plus the x takes this, and then 50 times 1,5 gives us 75. This is what I born, so 75. So that's what we have, guys, and now we need to write it in that manner. So therefore A is going to be, now you can already see what happened here. So if we say 50 divided by 1,5, what is it? 50 divided by 1,5, it gives us 100. So we get 100 over 3. But now I see something strange here. So I'm getting 100 over 3. But now there's an x in there, right? Right. And then plus, let's get to the next one. The next one is just that 4,5x. Hey, I am not happy. I am not happy. I am not happy. Why is this thing not doing what I want now? Hubaning ingeta so. Angas, but the answer I am getting is scaring me now. Anyway, 4,5 divided by 1,5. It gives us 3, so we get here 3x. X and x gives us a square. I feel like, okay, there's something I'm seeing, but we will see what to do about it. We will see what to do about it. Plus, now let's see 75 divided by 1,5. So 75 is 50. So this gives us 50 over x. So this is what I see. But now you can already see something happened here. So something happened. I'm getting a different answer, man. Hayi. Kanti benze ntoni abantu bona? What did we do, Tina? You know, part of me is thinking, but no, man. Why is that answer different from ours now? We should be having the same answer. You know? We should be having the same answer. But the answer is not answering. Don't go. When I get these questions, see, the last question is just 2 marks, man. Nenzentoni, guys. What did you guys do? The answer is not answering, man. The answer is not answering. But I'm very sure of what I did up there. But let's say we simplified that 25 divided by 1,5. This gives us a 50 over 3. Let me see if there's any changes. So let's say h. If we simplify that, it becomes 50 over 3. Then x squared, okay? Maybe let's leave it like that and see what happens here. Because this is similar to what we did, but now it looks very scary. You know? I'm feeling like, did we do the right thing? But let's try to run it again, guys, because hey, we can't be comforted by the fact that we did all the gymnastics. If the answer is not the same, then it means we must have simplified this already. So let's start. The total surface area here is going to be 2. We're focusing on the base. So the base is the area of base times height. So the area of base is, Yes, the area of base is length times breadth. So this is going to be x times 1,5x. Okay. So that would be the area of base times 2 plus the area of one of the sides. So this is going to be 2 times, again, 1,5x times the height, which is the one that we got, which is 50 over 3x squared. Ne? Okay, all right, okay. And then we're gonna say plus 2, one of the small sides. So this is just x times 1, not 1, but x times that height, which is the 50 over 3 x squared. Okay, now let's go for it. This is that. Now we know 1,5 times 2 is basically going to be 3x squared plus and then we're going to see what is going on here. Then we're going to have here 1,5 times 2, that's 3. No? Then the 3 takes the 3, so we get 50 over x squared. Let me see, what is this? So we're going to have 2 into 1,5 times 50 over 3. Okay. Yeah, that gives us 50. But now, remember the x will take the x, take the square there. So we get 50 over x. All right. And then we're going to say plus. We get to this one. Again, the same situation happens. We see that the x will take the square. And then we've got 100 over x. So I think there is a problem with this question because I'm still not getting what they gave us there. And this is worrisome. You see? This is worrisome. And you see, we're getting the same answer that we got. Now, how are we going to get this thing that they got, can't we? But do you see, one answer is here, though. I'm happy about this answer, but I'm not happy about the other two. So there's a problem with those. Anyway, let's see. A is going to be 100 over x. That one is good. We got it. And then no, it's not 100 over x, but 3x. Made a mistake here. So it's not. So this is totally outrageous. No matter what we do, we still don't get what is proposed. Hi. And Saibon, we born 10 learners say different. Okay. Yeah, I Buffett. What can you do? What can you do? This question is just asking things I don't know now. We're not getting the same answer. And I don't know, there's nothing wrong with it. We did everything right. But I'm trying to think now. Even if we try any tricks, it doesn't work. Hi guys, I don't know. Question. And so ndiyenze kabini ngithole the same answer. Kanti wrong lento ndiyenzayo. Hayi ndiyekeni. But part of me is thinking that I am actually not doing the right thing entirely. Because if we think about it, guys, the material for the box is going to be this. Okay, let's revise. Let's recap. Because if we're not getting the same answer, it means we're not doing the right calculations. Ne? So let's just sit back and think. Sometimes when you are tired and you're practicing a lot, this happens. Now remember, we need to think about the material used to make this one, as well as the material used to make that one. Okay? So I think this is where the problem is. So now we're not doing well, because to make the box, it was 2 components. So let's start there. Okay, let's start there. This looks all nice, but it's not exactly on point. We're gonna do it until we get it right, guys. So this is the 3rd run. So we're gonna talk about the surface area of this guy. So this is gonna be the area of the base. So the area of the base is just 1,5x into x, okay? Plus 2 times the area of the sides. So the area of the sides is 1,5x times the height, which is 25 over 1,5x squared. So that's the one. Plus the other one, the smaller sides. So this is going to be x times 25 over 1,5x squared. Ne? Plus, now we get to the box. Now the box has only this area, which is also on the other side. And then it has this area, which is also on the underside. But on the sides, it's open. It's opened. It's opened. All right, so we're going to say area of this base again times 2. So this is going to be basically 2 times 1,5x times x. Right? So that's the one. Plus. And then we're going to look at the sides. Again, there's 2 of them. So this is 1,5x times 25 over 1,5x squared. Right. So that's all. That's all. So that's the total material here. So A is, can you see 2 marks, guys, for such a nonsense? Hi, there's people. But let's see if we're going to get the same answer. So we get here 1,5x squared plus. And then for this one, we know that 1,5 takes 1,5, x takes the square. Then 2 times 25 is 50 over x. Okay. plus there again, the x will take the square, and then we've got 25 divided by 1,5 x. So what is that? It said 25 divided by 1,5 is 50 over 3. So this is 50 over 3x. Okay. Right. Then plus this one, 2 times 1,5, that's 3x times x, that's 3x squared. So this is 3x squared. Okay, I think we're creeping closer to what we wanted, but it still looks scary though. But I can already see the 4,5 here, this guy and this guy. But let's see what happens as we keep going. Plus that one, again, we're going to have 1,5 taking that and then that. So we're going to have 50 over x. Okay. So we're going to try and be as strategic as possible now. If we look at these, they somewhat look like terms. These ones. Right? Actually, yeah. But the problem is that the other 50 has a 1,5 in it. Anso nje into endingayifuniyo ngaye. Kuno 1,5 phaya endingamfuni. Ay, doch. It still is not happening. Question yawa Satan lena. Question yawa Satan wena man. Satan isukendleleni. Abone ndiyathandaza. Yanhlanyisa ke ngoku lento. Oh yeah, masiyeke leyana kanjeya. But I'm not happy still because these ones, nazi like terms apho zikhona. These ones are like terms. If we sort them up, what do we get? Common denominator is x for the both. Then we simply add the numerators. 50 plus 50, that's 100, so that's cool. Then we add the ones with the squares. So this is 3 plus 1,5. This is 4,5x squared. The last one is 50 over 1,5, which I don't understand. Did we mess it up, guys? I think so. I think so. This was meant to be 2 times, yes. Because remember, there's only one base, which is this. And then there's 2 of these ones. So which is these. And then there's 2 of these ones. There's 2 of these ones, which must be these. Yeah, so that is where we messed up. So I can see now what the examiner did here. They rather did not simplify, so we made a mistake, a small mistake. Can you see this is a problem, guys? Now we can see that it's 2 times 25, which is 50, over, this is 1,5x. Sure. All right, okay, all right. So that would be the story, guys. So 50 over 1, 5x. I don't understand why this is 2 marks. It's torture, actually. But hey, get a mark for this whole long lanky thing, and then for sorting it up, guys. Although the answer was given, I guess, yeah. As you can see, when something is not adding up, don't be stubborn, like I was. Try to be reasonable with your examiners. That there's no way they are wrong, guys, unless you have really proven. So you could see that we were missing something, and then we were supposed to then do it, because we want the material that did the box. So at least we got it eventually. So let's smile and move. If you can't prove this, guys, you can just use it here. You guys have what you call positive marking. You don't have negative marking. Yeah, so that's it. Let's see. Hence, determine the breadth of the box. What's the breadth? X. Such that the material used has a minimum. But why do you know that it would be a minimum? Remember, area is a parabola, right? Look at this. The coefficient of the highest highest power, x squared, is positive. So we know that when a is greater than 0, the parabola is concave up. And this means it has a minimum value at the turning point. So that makes sense. But now we can say our area is equal to 100. We write it so that we can differentiate. Plus 4,5 plus, then this is 50 over 1,5 x to the minus 1. Okay. All right, okay. So we can say for minimum, area, this will be dA over dx must be equal to 0. I'd like to try and continue on this other side. Let's first differentiate. So this is going to be minus 100x to the minus 2. This is going to be plus 4,5 by 2. That's 9x, right? And then minus 50 over 1,5 x to the minus 2. Let's move this one a bit. And then we say this must be equal to 0. Okay, cool. So let's see, this is going to be minus 100 over x squared, minus 50 over 1,5x squared plus 9x equal to 0. Looks like high chord. I'm gonna need more space. Let's rather leave this. It's not gonna finish here. We just carry on. So this implies that we've got minus 100 over x squared plus 9x minus 50 over 1,5x squared equal to 0. So we multiply by the common denominator. So we multiply by, we can say minus 1,5, or we can just say whatever we do anyway, it's up to us. We can multiply by 1,5x squared. When that happens, what do we get? So we know that the x squared will take the x squared. So 1,5 multiplies 100. So minus 100 times 1,5 gives us minus 150 plus, say 9 times 1,5 gives us 27 over 2 x cubed minus, and then what is this? 1,5 takes 1,5, so we just have 50 here, equal to 0. So these are like terms, so we end up with 27 over 2 x cubed is equal to, this is 300. Okay, so x cubed is going to be 300 divided by 27 over 2. So 300 divided by 27 over 2. This gives us 200 over 9. And then we take the cube root. Okay, so this means x is going to be, now let's see, we just say shift. Okay, let's just do it. Cube root of 200 over 9 gives us a 2,81. What was this? Centimeters. Nice. Okay, that was a bit of work. Quite a silly question, to be honest. And very little marks even. Yo, hehe. Saze sayibona indaba. Saze sayibona indaba. Siyibonile, guys. I hope everything is good. But if it is solvable, chances are we did everything right. Okay, so 3 hours are over, guys. So I don't know about the other questions that I wanted to slot in. There's quite a few questions I wanted us to look at, but the time buffet is not timing. So we're getting just 3 marks for such a nasty situation. Anyway, guys, this is to say the derivative, equating it to 0, and the final answer. The rest, the examiner is saying, well, you should know your algebra well enough to survive these questions. All right, let me take a small break, and we're going to look at a set of other questions that I would like to show you guys, but I think this video has gone on for too long already, and we tried, folks, to give you some ideas, but I want to take questions where we may use what we spoke about, sometimes issues of theorems, At least we were able to use trigonometry. We saw how to do that. Simultaneous equations, you saw that you solve one, take what you got and substitute into the other, so we did. But perhaps we want to look for a problem where we can use maybe some theorems, I suppose. And of course, we combine everything that we can find. But I think let me just take a short break and just let my mind be free a bit. And mind you, when I started this video, I had just come out of a class that started at 19 hours 30 to around 11. So I just ate and then jumped into this. So in any case, folks, I hope you are learning something and that you're gonna get better and better. And you can see some questions are challenging by nature. So you need to reconsider your strategy. You don't have it already made. And remember, by the time you do optimization, you are probably tired. So this is why sometimes as a student, you need to strategize. Which topics do you think you don't find so much strength in? You start with those topics so that as you get tired, you are simply doing routine work, which you can be able to do under pressure, even when tired. Now you can train yourself when you practice, especially now that we've almost covered the syllabus for grade 12, 2026, whether you are upgrading or you are a new matriculant for this year. You will see that when we start practicing, now try to take a paper from the difficult questions that you don't find strength in doing, as a second nature. Do those questions, and when you start to feel a bit tired, go to those sections that you master. But do not just break. Do those sections. Try to push yourself to concentrate, but you will see that you are not under pressure or stress when you're doing those sections. But make sure that you avoid those silly mistakes that come with tiredness. And you will see, guys, sooner or later, your endurance is going to be good. You will be able to sail through that paper as if it's knife through butter. And of course, leaving some time to look at those higher order questions, which are always there. There's always a glitch here and there, and that can take you a moment to figure out. But you can see we undo all the problems by rethinking, re-examining, and re-evaluating our strategy. It's not always going to be straight start to finish. Even if you know the subject, sometimes your thinking is flawed. Sometimes you're just forgetting something, So this is why you have to be wide awake when you practice this section by section. Then you combine these, starting with those sections that give you problems, and see how you perform on easy questions when you are tired, because you cannot perform on difficult questions when you are tired. You will be dead straight up. Those are the questions you want to eliminate first. Then go and buy time or even save time on easy questions, because those ones, when you look at them, you know what to do. But anyway, the strategy is to skim and scan the question paper. Also identify those questions that you think are going to cause you problems, and you start with them. Sometimes a probability which you think is difficult, when you look at the paper, you'll see that you've got all the answers for those questions. If you can, then you just decide, do you want to start with it and get it out of the way? You can do that, but you know that you're going to be saving time. Then you go to financial maths, if that's your weakest point again, and you look at those questions, you realize, well, I can answer all of them. You do that quickly. Because those are the sections you don't want to approach when tired, because you're not strong in those sections. And then you go to functions if you feel that you have troubles with functions. Then you skim and scan those questions. You realize, okay, I can answer these. You do that quickly. Then when you're starting to feel tired, you go to algebra, which is your bread and butter. Again, there you just make sure you have done enough routine work so that you don't struggle there. There will be higher grade questions, of course, but I doubt you'll be struggling to solve them. Then you go to sequences and series. Usually there's a predictable, but with some potential for higher grade questions. You do what you can. Then you feel like, okay, I'm tired. You still have maybe an hour, 30 minutes to go, or even, let's say, most likely 50 minutes or 45. Then you can just break for like 10 minutes or so. Just gather your thoughts, then come back, sort up those questions that are remaining. And if you have some 15 minutes to spare, you just try and check, skim and scan your solutions and see if everything is working, especially on those difficult questions where you're most likely to make a mistake. You are most likely making a big mistake, but even simple questions, as you can see, guys, this one was a simple question, but we fluffed it. So it happens. You find that you were stubborn and thought, so this was wrong. Actually, we were wrong because we didn't do the right thing. Okay, let's take that break, guys, and then we're gonna take some more questions. You must practice these. Practice these, guys, if you want to pass your major exams. Do these questions, all of them. Excuse me. Do all of these questions. Do all of these. All. With probability, we've already started with probability. We did most of these. Yeah, do all of this. Do all of this, guys. Do these things. Do them. Gooi, and pass. Can you see? There's more than enough in this document for you to practice for your paper 1. The entire paper 1. Different questions from different provinces, over the same time period, which might be very useful for you to go and succeed. Okay, let's do this. All right, guys, so let's carry on. So we're going to do this question 9. Now, this is from another document, but what I'm going to do, I will attach all the documents, be it the question banks, as well as this memo that we are doing, so that for reference purposes, you can look back and see what we have done. Now let's look at some technical questions. Now I'm not going to do some routine, easy questions to follow, but those questions that tend to demand a bit more attention from a student, and of course the more technical ones to answer. We are told here that after doing some research, a transport company has determined that the rate at which petrol is consumed by one of its large carriers traveling at an average speed of X kilometers per hour. Okay, very important rate of change is given by this business here. So this is the consumption of petrol per hour. As we can see that this is, whatever this is, liters per kilometer. Okay, right, liters per kilometer. Right, no problem. Now the first question says, assume that the petrol cost is 4 rands per liter, right? And the driver earns 18 rands per hour, okay? That is the traveling time. We now have to deduce that the cost C in rands for a 2-kilometer trip is given by this equation. Again, these are one of these higher grade questions where, working out everything is a bit technical. So it goes a very long way. So how are we going to get to that, guys? So we have a bit of a situation here. So remember, we've got the cost of petrol per liter, right? And we've got the cost of the driver per hour. So what we need to do here is to look at our 200-kilometer trip and find out how many hours would that be, okay? Because that way we can be able to work out from the hours how much are we going to have, and how much petrol as well must we pay for. All right, so let's just get to business. So we know, folks, that P of X is 55 over 2X. This is given, so we don't need to worry about it, right? This is liters per kilometer. So already, what is this? This is the rate at which petrol is consumed. Okay, the rate at which petrol is consumed for an average speed of X kilometers per hour. Right, so that's the first thing. So let's look at 9.1. So how do we solve 9.1? Excuse me. So obviously, guys, we know that speed is distance over time, isn't it? So that's what is important. But what we are interested in is the time here. Because once we know the time, then we will be able to, do some things. So the rate of change, we know that speed is going to be distance over time. Right? Great. So what do we know? The speed is x kilometers per hour. So this is x equal to the distance we're told is 2000, then over time. So we can already see from cross multiplication, the time that we have here is going to be 2000 divided by x. So this is going to be hours. Okay? So that's the first thing. So we know the time for this 200-kilometer trip. Now we want to go back to checking out certain things now. So the rate at which petrol is consumed, what happens when we multiply it by the kilometers? Because remember, we've got the rate per kilometer. Now we want to know how many liters will we essentially end up having over a 200-kilometer trip. So this means we're going to say the distance multiplied by what we have, isn't it? Because this is liters of petrol per kilometer. Now we want to know how many liters over this. So think about it. The rate of change, we're saying the rate here, this is liters of petrols per kilometer. So can you see liters per kilometer is equal to this value right here. If we want to know how many liters, we simply cross multiply the kilometers. So I hope you understand what a rate is. So now let's go for it. We can say now the liters of petrol over this 2000-kilometer distance is going to be, you can say L is going to be equal to, this is going to be 2000 kilometers multiplied by the rate. This is 55 over 2x plus x over 200. So if we simplify this, this is going to be 2000 times 55, or we can just say 2 here. Quickly, we just simplify and say 2 goes how many times? 8,000 times. Excellent. And the same will happen at 200 to 2000. Let's see. Let's just go for it anyway. Let's not waste time. 2000 times 55. Okay, divided by 2. It gives us 55,000 over x. Okay, already this is getting into shape. This is going to be plus 2000 divided by 200. Right, this is 10. So we've got 10x. Okay, so that's exactly the number of liters over the 200-kilometer distance that we are going to travel. Now, all is left is for us now to do the cost function, which is easy. So what are we going to do? We can say then the cost C of x is going to be the cost per liter multiplied by the number of liters that we have. So this is going to be 4 into 55,000 over x plus 10x, right? So this is going to be the cost of petrol plus the cost of the driver. So this driver earns 18 rands per hour. So we know the time t that this person is going to be traveling. So this is going to be the cost of this guy or is it the lady? We don't know. Let's just say the driver, multiplied by the time that this person takes. This is going to be 2000 over x. Okay, so this is very easy. All we do, we just simplify now. Distribute this. 4 times 55,000. What is it? 4 times 55 squared. This gives us 22,000. No, it's 220,000, sorry. Right, over x. Plus 4 times 10, this is 40x. You can already see something there that looks like it. But this is a like term to the other one. So let's see. 18 times 2000 is 36,000 over x. Now these are like terms, so we can add them up for the same denominator. So therefore C here is going to be same denominator, so we just put the denominator down. We then add the numerator, so plus 220,000, right? So this gives us a 256,000, right, over x plus 40x. And that's it. We've done it, guys. So it helps to think about how to do things. Again, you can see simultaneous equations here. We solve something somewhere, we put it in something, and then we put it all together. So this is just to highlight that simultaneous equations, guys, are very important, whereas the rates of change and all those things are also very important. So think of these things when you're solving such questions, because they can tax you greatly. All right, so how many marks would we score here? If we look at this, we can get a mark for deriving that. And then we can get a mark for deriving the amount of liters that we have over this distance. And of course, we can safely say this is also a calculation, as well as that is a calculation. So we have about 4 marks. And of course, the simplification, guys, gives us the final answer. Even though it was given, I think it's fair to give 5 marks for this question. It's not as simple. But you can see that once you know what to do, the approach is even more easy to go about. Now let's look at the next one. It says, hence determine the average speed to be maintained to affect a minimum cost. But if you think about it, why is this going to give us a minimum cost? Now, if you think about it, this is a quadratic equation. Although it doesn't look like one. Remember, hyperbola like this, when we differentiate this thing, we get a quadratic. Did I say quadratic? Well, let's say there was a value here. Okay? If there was a value here, when we want to solve here, what do? We're going to literally multiply by the denominator throughout. So this becomes x multiplied by whatever the value would have been, and that value. So this gives us a quadratic equation. So as you can see, it's a hidden quadratic. So that's why we know this. Okay, now let's set it up for differentiation. So we know that C is going to be, we write it in such a way that we can differentiate. So this is x to the minus 1 plus 40x. We can now say for minimum. As you would see, this quadratic would have been, the one with the positive, because remember, if you multiply x to this term, then the coefficient of x squared, which is the highest exponent, highest power, would be plus 40. So we can say for minimum cost, it will be such that C prime of x is equal to 0. Let's differentiate. So this is going to be minus 25,600. This is going to be x to the minus 2 plus 40 equal to 0. Okay, so let's get to business, folks. So this is minus 256,000 over, we convert to positive exponents. Now we've got options, obviously. Let's just leave it here and say plus 40 is equal to 0. We then multiply by the x squared, which is our common denominator. So this means we've got 256,000 plus 40x squared, not 4. 40x squared is equal to 0. Then we move everything to the other side. So this means 40x squared is going to be 256,000. And then, of course, we divide. So x squared is going to be, so 256,123 divided by 40. We get 6,400. And therefore, we see that x is going to be, we take the square root of that answer, it's 80. Again, this would have been plus or minus 80, because technically, we would have a cubic equation, isn't it? Yeah, something like that. So we choose the one with the positive answer. We can't choose a negative answer over a positive answer because there's no negative speed. Now we can say x is 80 kilometers per hour, right? So this is kilometers per hour. Is it per? Yeah. I think that's how we write it. Please don't forget the SI units. So this means if this person maintains a speed of 80 kilometers per hour, that's exactly what we're gonna get. Nice and easy, guys. Not a difficult question, but rather a technical question. So get used to these kinds of questions. They come up a lot. Okay, they come up a lot. So how many marks would you get? I would say perhaps, for just mathematical reasons, knowing that we need to set up our expression for differentiation, although I showed you how to do other means, the quotient rule and stuff, but that for me is mark worthy. Equating the derivative and taking it. So taking the derivative and equating to 0, I think that's good. And we can say for the final answer, you get your final mark. And of course, another person can say just 3 marks, the derivative and equating it to 0 and the answer. So it's a 3 plus or minus 1 mark to make it 4. Otherwise, guys, that question is sorted. There's not a lot to say. Now let's see. I've marked the questions that I want to do for you guys. There's plenty of them, but we're not gonna do all of them. We're just gonna choose some. So let's look at this question 18. I'm going to leave some spaces for you guys to make some notes if you want. Remember, this is going to be downloadable. Okay, an environmental study showed that the water from a factory polluted water in a nearby dam. Okay, the pollution had an effect on the water lilies growing on the water surface of the dam. At first, the polluted water caused the plants to grow in large numbers, right? And later on, it caused some of the plants to die, causing the area covered by the plants to decrease. Okay. So you see, at first they grew, then after that they decreased. Okay, so this looks like a parabola, isn't it? Because there's an increase, maximum, then it decreases. Okay, so that makes some sense. Right. Okay, so it says a mathematician established that the surface area, A, in meters squared, covered by the water lilies can be approximated by this formula. As you can see, this is a cubic now. It's not a quadratic. Okay, that's not a problem. It's okay. So it means they grew, they dipped, and then they grew again, whatever. Where it is the time in months, after the start of the study, you can see that the time is from 30 months, from 0 to 30 months. Okay, so this is a restricted function, and it's a cubic function. Okay, cool. Right, so let's start with this question. So we know that the area A is equal to minus 1 over 3 t cubed plus 10 t squared. Now this is a cubic function of this format. Right? Right. So most likely, when we checked this thing, we could easily have been looking at this position, going on to that position, you know? This was the rise and fall. We forget about the initial part. It's possible. In which case, we're most likely going to look at something like that. Or, you know, let's not talk too much. Let's just go. Because sometimes it's easy to talk a lot and lose the point. It says, after how many months did the area covered by the water lilies reach a maximum? Can you see that? So we basically want the turning point, because when it reaches a maximum, we know that at that maximum, this is 0, and we're looking for that x value. Okay, so this is very important to try and visualize what we are dealing with. So we know that, okay, for maximum area, well, what do we know? We know that dA over dt should be equal to 0, right? Right. Let's differentiate. So this implies this is just going to be minus t squared plus 20 t is equal to 0. Then we take out the highest common factor, which is minus t. So this is just going to be t minus 20 equal to 0. Obviously, this would be t0, t20. So we can see that t is going to be 20 months. Don't forget, this is months. So we're looking for the x at the turning point. So this means this is at the origin, 0. And this is at 20 months. So this is perfect for what we are saying. Can you see? Just thinking of the function that is perhaps involved in here and looking at its shape, you can almost tell which part. As you could see, that part is truly parabolic, but it's a part of a complete function that we looked at in a particular region rather than the entirety of that function. Okay, folks, so to take the derivative, we get a mark. To equate it to 0, knowing that the derivative at the turning point is 0, and we have an answer. So this is usually easy. 3 marks, sometimes you get 2 marks for this. 18.2 says, calculate the maximum area that was covered by the plants. So this is easy. So we know that area is going to be minus a third. Where we see t, we're going to put 20 and then we cube it, plus 10, and we're going to say 220 and then we square it. Essentially, the maximum area is just, we are looking for the y value at the turning point. That's what this is. So we're looking for the full coordinates of that turning point, essentially. Okay, minus 1 over 3 into 20 cubed plus 10 into 20 squared let's see, we get a value of 1333.33. Now remember, this is in meters squared, so do not forget to write the correct SI unit. If you don't, you lose the final mark, guys. Although this is easy, usually you would get 1 mark for this kind of a question, but for the sake of generosity of knowing where to put it, I can give an extra mark, but it may or may not be given. So this is easy, not so difficult. So always know functions, guys. We are always dealing with functions in this topic. No matter where we start, we may start from measurement, but we are going to model those measurements with known functions. Usually in grade 12, it's going to be either a cubic, quadratic, or linear. It's as simple as that. Okay, let's look at the next question. It says, at what rate was the area increasing 1 month after the study began? So what does this mean, guys? This is the gradient at a point. So the rate of the area increasing, this is the gradient. The time at which this occurs is 1 month. Remember, this is in months. So we just want the gradient at 1 month. So most likely something like that, and say here is the situation here. So this is 1 month, and we want the gradient at 1 month. And we know that this is a positive gradient at that point. So what is that gradient? So that's the question. All right, so we know that, folks, this is very easy. We can say the rate is going to be equal to this first derivative. What did we get? It's minus t squared. Now instead of t squared, just gonna say minus 1 squared plus 20 into 1, isn't it? So that's what this is. So you can say therefore the rate is going to be, so we know that 20 minus 1 is going to be 19, but 19 what? Meters squared per month. So this is meters squared per month, because that's the rate here. Okay, so that's it. So the area here was growing at 19 meters squared per month, and we know that this rate changes every point. Okay, at every point it changes, it's different. Okay, so this one, guys, it's as simple as just maybe 1 mark for the answer or 2 marks for the answer. It doesn't matter. We can be generous and give 2 marks. Right, 18.4. So this says, sketch the graph of the area covered by the plants versus time. Show the intercepts with the axis and the turning point. Right. So this is good. Again, this is to say master functions, guys, because at the end of this topic, you may be asked a question like this. And we saw that this one fitted a very nice shape of a graph. So this graph comes stuff like this, and it goes, no. And let's do the point of inflection, and then we can do it. So as you can see, it's just a cubic function, guys, that at the origin we saw that there's a turning point, which is also the y-intercept, and we could see what was missing. It was the t term plus the constant. It means there would be a turning point right on the y-axis, as well as, at the origin, as well as that being a common intercept for both x and y, as well as the turning point. So let's just show what this examiner wants. What does this examiner want from us? We saw that this was at 20, right? And we know that this is the time in months. Please don't forget, so this is the area in meters squared. Now we saw that the corresponding y value here was essentially 1333,33. Okay, it's as simple as that. And what is that x-intercept? Hey, that one. What is that x-intercept? I think that's the only thing we need at this point. But this is a nice cubic, because if we factorize this one, we're going to take basically t squared, and what is left is minus a third of t plus 10 equal to 0. And we can already see that if we transpose the 10 and then we cross multiply the 3, it gives us 30. So this is going to be at 30, that one, right? Or you can easily say minus 10 divided by minus a third. When we do our gymnastics, it gives us 30, so we are good. So we've shown the turning points, we've shown the intercepts with the x's. So first and foremost, guys, get our marks for the shape, because knowing the shape is key. And then we get our marks for the turning point, any one of the turning points, and for any one of the intercepts with the x's. So this is a nice 3-mark question. Nice and easy. Now obviously, guys, are you going to get a mark for showing what I have shown? No, you're not. So remember, there's a restrictions. Now there's a restriction here. So this means this part is not considered. So that part must not be there, guys. And where this graph ends, we put a nice lovely dot. This is included because this said greater than and equal to 0. And we don't also want this part. It's not included. And of course, where it ends, this is exactly what we should. So again, I suppose the 3rd mark here could be considered for, we said, turning point, intercepts, shape, perhaps to also adhere to the restrictions, because this is a restricted graph. So to make sure that we drew the graph to the domain, we can add an extra mark, just for fun. Why not? Why not? Yeah, we must. All right, guys, so that was a nice question, and you can see this was NSC June 2009. So you can see the quality of these questions, and especially when it comes to restrictions, because these are things students don't look at. Okay, that's it for this question, guys. We are done with it. Now let's take the next one. So as I said, we need to look out for some sort of functions and some distances between them. This time you can see AB is a diagonal distance. So what are we going to do there? Let's see, question 19. So question 19 says, sketched is the graph of y is equal to x squared. Okay, this is a parabola. And A with the point t and t squared, and then B with that point on the x-axis are shown. Okay, now it says A is a point on the curve y equals x squared, and b lies on the x-axis. Now show that ab squared is this. Okay, this is very easy, guys. Distance formula. Once you see a slant height, a slant length, you know it's going to be distance formula. So 19.1. We know that ab squared is going to be x at b minus x at a all squared plus y at b minus y at a. Can you see? You expect this in paper 2, but it's going to come up in paper 1. So this is 3 minus t all squared plus 0 minus t squared all squared. So let's go for ab squared. Is going to be, when we fold this out, it's going to be 9 minus 6t plus t squared plus. Okay, this one is going to be a bit tricky, but we do this. It's going to be basically plus t to the 4, isn't it? Yeah, because it's an even exponent. So this is going to be t to the 4. So that's easy. So we can just write, therefore, ab squared is, we write them in descending order of the exponents, not t squared, but t to the 4. So this is t to the 4 plus t squared minus 6t plus 9. And it's exactly how this was asked. Okay. Great. So let's look at 19.2. 19.2 says, hence determine the value of t which minimizes the distance right at AB. Okay, not a problem. So when we say minimum, we take a derivative here and solve. All right, okay, all right. Now with the quartic, or is it, this is a, remember this would have been something like this, but then there's this part also, so it looks like that. So what are we saying? Minimum. Now for this to be a minimum, obviously this is a distance. So this already tells you and I that t cannot be negative. Chances are you would find that this is at the origin, right? So most likely the minimum that we're looking for is this one, okay? Not that one, because the t there is negative. So it's definitely not that one, but the other one. Again, it helps to visualize what that looks like. But again, I'm just giving you guys some ideas. These are beyond your level, but you will almost see that if it's a quartic function with a positive coefficient of whatever this is, you just split it into a cubic, that would have a positive and then you put an extra, x squared over there. So that would be a parabola that is like that, plus, so imagine a parabola that was concave up and a cubic function with a positive a value. Or something like that. You just think about it. You think about it. Okay, guys, so our job here is to look out for that value. So that's the t value that we're looking for. So we know that, okay, for minimum distance, it will be such that you can say d ab squared over dt. So don't worry the fact that this is ab, but we can still do something with h squared. Remember, nothing has changed much. So this must be equal to 0. Okay, so what do we have here? This implies that 4t cubed plus 2t, right, minus 6 is equal to 0, right? Right, can we factorize this? I think we can. Because if t is 1, for example, this gives us 0, because this is going to be 4 plus 2, which is 6, minus 6, that's 0. So we know that t minus 1 is a factor here. So just by inspection. So we know that we've got t minus 1. Now we know that the other one is going to be a quadratic. So what must we multiply with t to get 4t cubed? It has to be 4t squared. And then, what must we multiply minus 1 by to get a minus 6? It's a plus 6, right? Then we can look at the middle term. How do we get this? So we already have 6t. Now this minus 1 is going to multiply something, so this must already be a plus 2t. So when we multiply by minus 1, we get a minus 2t. So we've got 6t. No, wrong, 4. This must be 4. Right? So we know that when we say minus 1 times plus 4t, it's going to give us minus 4t, and 6, that gives us 2t. So everything looks nice and set. But do we get an x squared? So not, because this t times that, it gives us 4t squared minus 4t squared. So they kill each other. So this is nicely factorized. So we factorize it further. T minus 1 into, this is quadratic. So to get this, we have 3 and, let's see, 3 and 2. 3 and 2. Okay, so let's see, this must be 2t, right? And then the other one must be 3, the other one must be 2. Does it work? Let's see, this is 4t squared. 2 times that is 6. Then 6 plus 4. It doesn't work. Alright. Let us think. To get that 4. Lord. At some point, let's check the discriminant here. Is this thing factorizable? It looks like it is. I'm trying to think. But it certainly cannot be 1. You know? It certainly cannot be 1. Because we already saw, no, it's a different question, excuse me. Okay, it may very well be 1, it's possible. But I'm just thinking, is this thing factorizable? 6. It's 3 and 2, okay? And everything is positive. So let's just say plus. But now how do we get 4? This doesn't really help, eh? 6 plus 4 is 10. So it's not working. It's not working. I think the roots here are non-real. Let's just check. I think they are non-real. So let's see, what is the discriminant for that? Discriminant is going to be 4 squared minus 4 into 4 into 6. Yeah, it's certainly going to be negative. So that is non-real roots. So we cannot factorize the quadratic one. So definitely this is just 1. Okay, sometimes my suggestion is, once you get these quadratics, especially in this type of a topic, just check the discriminant before you waste time trying to factorize. Because as you can see here, there's no solution, because this one doesn't touch the x-axis. So you can easily see that there's no solution. So because of that, we can say t is equal to 1. So t must be 1. Excuse me. So what is this 1? It's just 1, okay? So the value of t is just 1. So it's 1 unit or just 1. It is not a big deal. So we could easily go and calculate that distance if we wanted, right? So some person may say, hence calculate the distance AB. Let's do it, because now we are on the final stages of this review. So we can say here 9.3. Hence determine the minimum distance of AB, right? And of course the answer to this, we are going to take the AB squared, or maybe say AB is going to be equal to the square root. Now we see, where we see t, we're going to put 1 to the 4 plus 1 squared minus 6 into 1 plus 9. Therefore AB, so square root of 1 to the 4 plus 1 squared, right, minus 6 into 1 plus 9. So this gives us square root 5. You can leave it here, unless someone says to 2 decimal places if you must, but I can leave it as root 5 units. Of course, you can go about it however you choose. You can do decimals. And of course, guys, for this one, you would say for the gymnastic, and knowing that you need to take the square root, maybe 2 marks, maybe 1 mark, whatever. All right, let's get to the next question. I highlighted the ones that I want us to do, guys, so that we can do things. We did this. Okay, we did most of these, but I want some nice one. I want some nice one. Tired of functions now. I am tired. I'm tired. Akukho interesting here. There's nothing interesting, Haibo. There's a question I was looking for, man. Where is it? I've done this one in the channel, I think. I've done this in the channel. There's a video on this one. So I won't even bother wasting my time around it. You guys may have to try a question like this, you know, just see how well you're gonna do. Obviously you're gonna be asked about this area. So what do? Well, obviously, let me just tell you the plan. I'm not gonna do this. You just need to know how to approach these questions. At some point I can't spoon feed you, eh? You look at this rectangular space, right? And with this rectangular space, what are you gonna do? You then are going to take out this area. So you calculate the area of the rectangle and you take out the area of that piece, and you also are going to have to take out the area of this piece, right? And you're going to take out the area of that piece. So the area of the complete rectangle minus the area of those triangles, it will give us this area. Then from there, you do your things, guys. So practice these kinds of questions because they like to come. All right? You will always have to deal with this. I mean, seeing that this is a rectangle, remember, the properties of a rectangle is that the opposite sides are literally equal. So if this is x and that was 40, so this distance is going to be 40 minus x, isn't it? So you've got the dimensions of that triangle. And we know that the corner angles in a rectangle are 90 degrees. Right? So those are right-angled triangles. So you are sorted. Again, if this is 2 meters and this was 60, so this means this one is going to be 60 minus 2x. Okay? So you've got enough information now to work out the area. So please do it. Do it, guys. It's 4 hours. I feel like I should stop. I should not do everything. These are easy, man. I know you guys panic when you see these, but they are very easy. So just practice. I was looking for something interesting, but I'm not getting it. So again, try questions like this. Again, this one is going to be all about finding this area. You know, again, same approach as the other question. So to get this area, this means you need to eliminate this triangle, right? And you need to eliminate that triangle from the area of the square. As you can see, this is a square. Then, of course, you're going to have to eliminate that triangle as well. And eliminate this triangle. They look okay. They look like they are the same. In fact, they are congruent. Why? It's a right-angled triangle. So you've got this side, that side equal, this side equal. And, of course, the hypotenuse would be the same. So got the right angle hypotenuse side property of congruent triangles. So you eliminate those ones, you will be home free. You will be home free, okay? All right, okay. Nice. So again, it's very easy. So solve that question, guys. I've already shown you the approach to get to it. Unfortunately, guys, I'm not going to do every single question. There are some interesting questions like this. Again, similar idea. If I can tell you the approach here. Okay, this one is a bit tricky. It's not as easy as you would wish. Maybe let's do it. Maybe let's do this one as our last example. Yeah. I'm tired. And I'm experiencing a bit of heartburn. I don't know why it's intensifying. Heaven. Okay, guys. So this one was from November 2002. Okay. This question. As you can see, in Limpopo, this question was asked in 2023. So you're not going to run away and not do these questions because they're from 2002. Whatever you can get your hands into, guys, do it. So you can explore yourself there. And then there's nothing else. Okay, that's it. So this one, you will see, guys, I'm going to share this document with you. So what do you say? What do you say? What do you say? What sayest thou? Thou sayest nothing. So here's another problem. We solved it already. I think what I wanted to cover, guys, was good. But perhaps let me show you this question. It's quite interesting. Again, it was asked recently as well. So let's see. So this is question 24. I'm going to make this one the last. Or maybe I'm going to look for one question that has theorems involved, because I need you to remember that. Okay, let's not talk. It says Devon wants to cut 2 circles out of a rectangular piece of cardboard of 2 meters long times 4x meters wide. So these are already shown. The radius of the larger circle is half the width of the cardboard. Okay, so the radius of the larger circle is half the width of the cardboard. Ne? So what does that mean? This is going to be 4x, because the width is 4x, and then you divide it by 2. So that's the radius. So again, you need to put sense into what you are reading. And the smaller circle has a radius that is 2/3 of the radius of the bigger circle. So this means this guy. If we can say this is R1 and then this is R2, this one is going to be 2/3 of the radius of the bigger circle. So this is basically 2/3 times 4x over 2. So that's what we are being given here. Now, what is next? It's anybody's guess, guys. So the question says, show that the area of the shaded region is like that. Okay, let's quickly do it. Stop wasting time. So 24.1. We know that we're going to take the area of the rectangle, subtract this circle, and then subtract that circle. Then we have the area of the shaded area. So this is done by elimination. So we can say here, well, area in terms of x, it's going to be length times breadth, which is going to be 4x times 2 meters. And what are we going to do about it? We're going to say from here we subtract pi r squared. Now the r here, this is 4 divided by 2, which is just 2x all squared minus. And then the next one is going to be minus 2/3 of pi okay, I lied, guys, excuse me. Minus pi, the r here, as you can see, this is 2/3 of, whatever that is. So this is 2x times 2/3. So this is going to be 4/3. So it's going to be 4/3 of x all squared. So area in terms of x, this is going to be 8x. You can already see there, it's coming up nicely. Minus, these are like terms. So this is going to be 4 pi x squared minus, so it's going to be 16 pi x squared over 9. Now these are like terms, so we can add them together. So this is 8x minus, so say 9 times 4, that gives us 36. 36 plus 16. Did I say 36? 9 times 4 is 36, no? Yeah, and then we add 16, we get 52. So this is going to be minus 52 pi all over 9 and then x squared. So this is done. I think this question was easier than I thought. Thought it was going to be a challenge, but it's not. Okay guys, so obviously we get a mark for this business, that business, and that business. I think it's significant. And of course the simplification that led to this one, you can say easily 4 marks. 24.2 says determine the value of x such that the area of the shaded region is a maximum. Why would it be a maximum? You saw that this is a quadratic with a grumpy face, right? The coefficient of the highest power x squared is negative. So this will definitely have a maximum. Okay, you can just say for maximum area, right? We know that a prime x must be equal to 0. Please be careful of the notation. So this is going to be 8 minus 52 by 2. It's 104. So this is going to be minus 104 all over 9. Pi x, excuse me, is equal to 0. All right. So this means that minus 104 over 9 pi x is going to be equal to minus 8. Therefore, x is going to be, just say minus 8 divided by minus 104 pi right, divided by 9. So this gives us a 0.22. What was this? Meters. Okay. So that's what we have, guys. So it's okay. I can take it. I can accept it. It makes a bit of sense given the structures. All right, so how many marks? To take the derivative and to get the value of x, guys. I think this one would be 2 marks, maybe at the very least 3. At most, not at the very least, at most 3, at least 2. Certainly not 1 mark, okay? 24.3 says, calculate the total area of the circles if the area of the shaded region is a maximum. So we want the total area of the circles. So we know that area of circles is going to be the first one, pi r squared. Now pi r, the radius there, we saw that this is going to be 2 times 0.22 squared plus this is pi into 4 over 3 times 0.22 squared. You can say therefore the area of the circles is, let's get to business, pi into 2 times 0.22 squared plus pi into 4/3 of 0.22 all squared. So the answer there is 0.88 meters squared. Right, I hope everything is cool. Okay guys, this one very easy. We can say for substitutions and for the answer, or just 2 marks for the answer only. All right folks, now I want to show you guys the last one. Yo, this heartburn is killing me, and I drank things I should not drink at this hour. And now I need milk. Let me just drink some milk, you know. Okay guys, let's take this last question 9. I believe this is from the Eastern Cape, September 2025. Okay, so you can go and find this paper, but again, I think this question you can just screenshot it and do it. There's no need to have too many question papers, but if you're interested in doing questions on this paper, maybe I should attach it in the description as well. So let's just say all the pieces of information used here, you will be able to download in the description. Now guys, I was just looking for something interesting. I couldn't, but I think this question is also a bit interesting in that you need to deal with word sums. Sometimes when things are not fully known, but still apply calculus to answer the question. I told you the sum of 2 numbers is 25, okay? So we can just say let the numbers here be x and y, such that x plus y is 25, isn't it? So that's the first equation that we are given. Second, it says determine the 2 numbers such that the square of the one number plus 3 times the square of the other number is a minimum. So we can also say here, also we can just say let a be the value of these squares. So we know that the square of the one number, we can say x squared plus 3 times the square of the other number. So we can say 3y squared. Let it be a. Okay, so we can say a. Can you see? We also introduced something that was not there, because we have to have an equation for us to differentiate, but we could actually differentiate whatever this is as an expression. But the tricky part would be if we don't have an equation, we can't solve for these numbers, and yet we need to solve for the numbers. Okay, cool. Now we need to eliminate y. We can say therefore from here we can say y is basically 25 minus x. Right, maybe let's make this one equation 1 like this. Right, and then this one is going to be equation 2. Or we can even conclude that a is x squared plus 3 into 2x. This can't be 2x, 25. Here when I was on Betis. I am already losing focus. I should stop indeed here. So this is 25 minus x all squared. All right, maybe let's simplify further. So therefore a is gonna be, actually this thing is gonna be even more, so let's be patient, let's not rush. All right, so this is going to be x squared plus, now this is 3 into 25 squared, 625, ne? Minus this one times 2, it's going to be 50x plus x squared. Therefore, I just want to end this pain. Now we're going to have x squared times 3. This is 3x squared plus, it's going to be 4x squared. Plus, is going to be minus 3 times 50, this is 150x, and then 3 times 625 is 1875. So this is what we have, guys. So can you see, from just a simple thing to a complicated stuff. Now we can say for minimum, A value, whatever this is, right? What should we say? We can say dA over dx is going to be 0. So what do we see there? This is going to be 8x minus 150 equal to 0. And 8x is equal to 150. Therefore, x is 150 divided by 8 is 75 over 4. Right? And therefore, y, go and take the easiest equation that we derived. What was it? We know that y is going to be 25 minus 75 over 4, which is going to be equal to, all right, what is it? It gives us 25 over 4. Nice and easy. All right, guys, so that is the story. We wanted these numbers. When the distance or whatever they sum up to in terms of their squares, of course, we need to, this is AQL, folks. Academic and quantitative literacy. By the way, I did take notice of your request, folks, that I should do the QL questions. I was struggling to find the green book that you guys were referring. Is it blue? I think it's blue. I was struggling to find that book until I found it on some site. So I'm going to be doing those questions throughout the week, NBT related stuff. So now, folks, I think since we've covered most of the topics in our channel, you have no excuse to fail maths, paper 1 and paper 2. I've done more than you needed. Guys, I've taken you through the big topics in a big way. I've done full papers in this channel and some, questions that stand alone where I wanted to expand some concepts that can be used. So folks, you have no excuses. If you don't practice, you think you're going to watch and you think you're going to know, you're not going to win. If you don't attend classes, and when you do, you don't participate in the classes, you're going to miss out on such a great opportunity, and which is for mahala. Aibo, guys. You can win the we are underprivileged. We are from poor rural backgrounds. I go and die somewhere, man. Ngazosifundeke Latin. Nikumba tina sugapi. Tina sugapi. Are we from the affluent areas of this country? No. We are from the poorest of the poor. I'm a village boy. If you look at my village in Mount Fletcher, Ezingonyameni location, you would laugh. You wouldn't believe I'm from there, of course, looking at how far I have gone with my education and how enthusiastic I have been of every opportunity to learn, such that you wouldn't place me there if at all you didn't know or you didn't see me there. Okay? So folks, indaba ye-sob stories ayisebenzi. We don't want to hear your sob stories. We have a lot of our own. Sometimes it would sound like fiction if we were to tell you where we've come from and how it all started. You wouldn't believe it. You would start to realize that what you're crying about, it's nothing compared to what others have experienced. I also know that some of my experiences, especially the ones that I regard as the most difficult or the scariest or the most challenging, are nothing compared to what another person can share as their story. I would start to realize that I'm a snob, actually. I'm a crybaby. Because there's people who've seen worse, guys, but still made it through it all. Some guys have lost, their limbs along the way, but they still managed to get their medical degrees and they're now doctors. Others would have given up and say, so if I don't have a leg, I cannot do this. They just continued because, look, no one knows what's going to happen. So to sit on your sub stories is an insult, okay? And you cannot be, playing around with this. I am from a poor background. Look, guys, you don't have to have rich parents to go to university and study whatever you want. It starts with your high school work. Or let's just say schoolwork. If you don't do your schoolwork, you don't handle your business as a student, you're busy trying to do adult things. You want to have girlfriends, you want to have boyfriends, you want to spend time with people who are just simply wasting yours and theirs alongside sometimes. But sometimes you find out that the other one who's wasting your time is actually using their time and using you as a distraction. And sometimes it really goes bad for the one being used, because the one who is using, they're actually benefiting, because for them, you are just a form of a break of some sort, a form of a distraction that they need to balance their lives out. But are you having yours balanced before you become somebody else's, tool or something? For me, you school-going kids, you should just forget about the stupidity, chasing relationships. Even adults cry like kids when these things go wrong. So it's not easy. Even marriage, guys, it's not easy. When you finally marry somebody, you will find out that you just put yourself in some kind of a jail, okay? These things are not heavenly as we say they are. They can be quite devilish instead. Seeing people break through these nonsensical beliefs that we hold, instead of just looking at what works. And of course, remember, maturity is important before you can marry someone. You need to realize most of your, I almost said something wrong, but you need to realize most of your fantasies. Deal with them, finish them while you're growing up. Don't rush. Finish all of these things, because these are going to be the problems in your life if you don't get over them. And sometimes these things, the only way to get over them is to actually experience them eventually, not early, of course. Eventually experience these enough to realize that they are meaningless, so that when you start a journey of raising a family, having children, and all of that, you have finished being stupid and fantastic. You are now more realistic and a visionary at best. You know what to sacrifice, when to sacrifice, why the sacrifice, okay? And you know the how part as well. Even when things go wrong, how do you control the situation? Don't just explode and cry, okay? So please, folks, remember, if you want to become something better, get your marks right. And it's easy nowadays. Even utilili you can watch a video on YouTube. Phone just stylo. I have a stylo here when my phone was not working well and I hadn't bought my new phone. I had my stylo there. My stylo could open a video on Facebook, could open a video on YouTube. I saw some of my videos on that phone. It's a ngutilili with 300, 400 or so. All right? So even those phones, guys, you cannot make an excuse and say, hi, mna, because I don't have an expensive tablet. You don't need those. Just as cheap a phone as the one for 400 rands that can play a video. Watch these things. Spend whatever amount of money you have on these videos. If you can't watch, download it so that you have an unlimited time of watching and not needing to use a lot of data. Because if you download, you're not going to use a lot of data as when you watch these videos one after another online. Okay, just watch and learn and master. We didn't have this privilege of seeing people who have experienced this subject better than just high school education and whatever. People who have seen it in practice, as I often show you, the areas where these things apply. Those people have essentially come up here now, and you get to see these things in different levels of study. So folks, you cannot make excuses because you just need to get a distinction in your maths and physics. You get a bursary or a scholarship. There's even international scholarships where you get a scholarship in the US or somewhere where you can go and study there even if you never had money, even if you walk on barefoot like I used to with calloused feet, because almost in the village, you could end up a Harvard student on a scholarship. Okay, so please guys, dream big, and remember, it's all in your hands. If you don't handle your business, no one is going to save you. Even miracles do not happen for someone who is unprepared, because a friend of mine told me that the so-called luck sometimes is not really what we call it, but technically when it is to be useful, it is when an opportunity meets someone who is prepared. So it's basically luck is when opportunity meets preparedness. Because if an opportunity comes and you're not ready for it, you lose it. And you may never find it again. I have suffered already in that regard. Because I got a few opportunities when I was not mentally ready for them. And I suffered. Now I'm suffering. Okay, I am causing myself to suffer because of the anxiety and all, but technically I am not suffering. I'm just causing the pain to myself by obsessing over what is spilled, which is not supposed to be the case. So anyway, guys, I have done what I could for you, and whoever requested this Lesejo, I hope you have been able to enjoy these videos. And I think I have done most of the questions that you could get. But remember, the examiners are skilled, so they will keep creating challenges for you. So use these challenges as a way of stepping up. Don't expect these kinds of questions per se in your next exam, but rather use these as stepping stones to go up to the level of any question that you can come across. Again, as you can see, guys, word problems are very important. It's important to get this equation and to get this equation and eventually this one. So 3 marks already in the bag. To differentiate 4, equate that to 0, 5, then 6, then 7. Can you see? All the 7 marks in the bag without a flinch in your eyes. Okay, guys, I think this is the end of my video. Of course, when I find some interesting questions, I am going to post them individually. I do not want to make a habit of overly spoon-feeding you guys. At the same time, if you only watch me, you're going to go and fail. I can promise you that. Watching me do this thing is going to make you feel like you understand it. But remember, I'm not going to be there in the exam. So if you did not subject yourself to this torture of discovering things by yourself, getting used to seeing patterns, even on new things that you have not seen before, you will not make it in the exams, because most of these questions you're going to watch me show you. You're not going to win. But I am very happy though that the students who seem to watch my channel, by seeing their interaction with me either in the comment section or those who end up joining my classes on Google Meet, and those that end up joining our WhatsApp group, I see something very interesting and very positive in that these guys subject themselves to the torture. They are not afraid to go to the limits. Wrong or right, they don't mind being wrong, because then they later become very right. Okay? So I'm very happy that the interaction I'm getting, it's people who actually see an improvement in how they do things. I just hope, guys, it's not you being lucky to see some of the things that I show you, but rather you are able to use everything I have shown you from your understanding standpoint, so that you are applying these things effortlessly as you do these exams. I would be happy if that's the way. Fact of the matter is that you need to acquire the skills, guys, so that you can apply them anytime and anywhere when you need them or when you have to apply them. Okay. Anyway, I wish I could preach for you guys and preach and preach and preach, but it's not gonna happen. Okay. It's not gonna happen. Okay, guys, currently in our classes, for those who may watch this video and still be interested in joining our WhatsApp group, of course, you've got my number in this channel, so look at the description of this channel or whatever they call it. You go to the exact channel now, you check there on the information, you will see my WhatsApp number. You will also see my email address. Whichever you choose to contact me with, you are welcome to do so. You can ask a question, you can ask to join. Our group, guys, is joined for free. You don't have to pay any cent. So call this some sort of giving back type of a situation, because I truly have benefited from public funds to get where I am. I'm also a beneficiary of many people helping me along the way when they didn't need to, but they did instead. In fact, they did it as if it was a duty for them to do it. So I felt it would be fair for me to also do the same to as many people as I can reach through this media platform or social media platform. That was my intention, guys. Always, I've been wondering over the years, how would I be able to share the little bit of the skills that I have acquired throughout my high school career and through my university years. And of course, what have I realized along the way up till now. So I didn't know how to do this, because to teach at a physical school would be limiting the spread of fire. We need to spread this fire like it's crazy. It's like there's a wind and it's winter, right? So we need to do that. Yeah, folks, it's up to you to take advantage of these, but you may choose to turn a blind eye onto them until you are desperate, in which case it's not going to work for you. I'm sorry, that's just the reality. It's very few people who can use these under those testing and trying moments and succeed, but those who have not been doing their part cannot take the benefits of the presence of these videos. So remember, these videos, guys, are not to do your work for you. They're just to show you how to use the very basics that you are being taught at school and that you've been taught throughout your schooling career, to use them to solve some complex problems. That's just the intention of these videos. They are not here to supplement. No, they are not here to replace your work. They are just here to show you how the work is done, and not just how it's done as a routine, but with understanding, because that's what we're trying to get to you guys. It's for you to understand all the work that needs to be done so that you can become a free thinker. You can think by yourself, realize more, do more. Because you will see at university, there's no time to repeat things there. If you didn't catch it the first time, you are likely to fail that block, only to have to repeat it in the following year. There's no time to play there, guys. There's no exams that sum up to the finals. Sometimes you don't even qualify to sit for the finals as a life-saving maneuver. If you fail so badly, you will not be given a chance to sit for the finals, because you need a certain minimum percentage to get into the final exam. Then for those who surpassed a certain landmark, they get what we call an exemption. You don't have to sit for the finals. If you passed in such a way that you really, really, really don't need to sit for the finals, you then are allowed to go. But in that case, let's say your year mark for a particular block is 75%, right? And if you score that high, they allow you to be exempt from the final exams. So obviously, if you take that option, your mark is going to be 50%, okay? You're not going to get that 75% that you got. But if you want to keep your 75%, then you go to the final exam and you score some more marks and try to keep it or even extend it so that you can have a distinction. There are some people who are so much into cum laude passes. For me, okay, it's good. You can have those, but nowadays, guys, in this world of today, scooping up distinctions doesn't give you any better opportunities than someone who passes well and understands their work, because you will be put through a test with your accolades. Yes, you'll be first preference, but you will fall badly, because you will see that a position that you expected to get nowadays, you don't get. And someone you don't expect to get that position actually does. Because if those people can demonstrate, first, if you are to be given an opportunity for something, what people look for is, are you teachable? Are you able to learn anything? That's the first thing. So your arrogance and your ambitiousness, sometimes you need to check it. Yes, you must have an ambition so that we can see you can take it further. But you have to combine that with a sense of humbleness. You need to be humble and also be realistic. Okay? Also demonstrate your capabilities. What can you do so far now that you are at that level? There are people who hold cum laudes, but they can't represent them in any way. Because remember, when you come with those fleshy colors of results, you'll be asked tough questions in the interviews. You know why? Because we are testing whether you are a true representative of your results. If you so much as give us the impression that, well, you have fluked those results, trust me, someone who somewhat scored under you in terms of those kinds of results will be then given an opportunity for an interview as well. And if they demonstrate proficiency, I'm telling you, you will be left in the cold with your excellent results. So be very careful. These things are the way they are. So be very careful, especially if you're a man or you're a young man, because there's a push for females now to be, in every place there is imaginable. So you are not the preference by default if you're a man. So be very careful, guys. Take your opportunities when they come, because they may never come again. So we have this gender situation going on. Instead of people just, showing up as ready for whatever is to be given and they take it, there is a preference to certain individuals. And they're even making it a racial thing now. So they want to prefer certain race over another, which is unfair. Yes, South Africa, guys, is an unequal society. From, our recent history or recent past, if you will. But look, folks, it's been 30 years now. We are 32 years in democracy. Look, democracy says you decide what you want, as long as you don't encroach on other people's rights or, do things that are not legal. In democracy, folks, you can determine your future your own way and as far as you want to go. I understand we cannot downplay the fact that our parents and those who those who came before them, they suffered a lot of restrictions in what they could do. But at the same time, guys, we have been given an opportunity to redeem ourselves. I don't understand why we have not. Instead, we want to sit with complaints. We want to sit with cries. It's even silly for a young person of this generation to even talk about the past. What do they know about the past? They don't know it. They've never seen it. They came long after it was gone, okay? Now, you can't even start to blame your parents for your misfortunes, because, why did they bring you into this world if they were not ready to support you in all ways possible, or something within their reach? Because they don't have to be educated to educate you. They just have to find work and be consistent at it. Save money for you so that you can get the opportunities you need. And a lot of parents make a mistake of taking their kids from a township school to some, Model C school or whatever that was called, but those private schools, because they're thinking the education there is the best quality over and above, the public schools, especially in the townships. Look, guys, we are the products of rural schools, okay? I attended rural school from sub A, which is what you guys call grade 1, until standard 7, which is grade 9. Never been anywhere else but there. Imagine I have not traveled anywhere during those years. From 1994 when I was doing sub A up until 2002 when I passed standard 7, I have not traveled elsewhere except within and around the rural towns. Usually I would go to my mother's hometown, Qumbu, at Ekalankomo village. That's where I would be going on holidays. If I didn't go there, I would be right at home in Mount Fletcher. I've never been elsewhere in those years. Then from there, my brother took me to Gauteng, specifically at Tsakane, right? And specifically where in Tsakane? Langerville Extension 5. And it was a slum area at the time. There were just slums. And those, of course, who had money were able to build a few houses. Of course, my brother and his wife had a bit of money, of course. They built a decent 2-roomed house where we used one as a kitchen and they used the other room as their bedroom. And there was a umkhukhu ngaphandle, so I slept in the kitchen on the floor and my sister's sister left in the mukhuku outside. So guys, we are from nowhere. Believe me when I tell you, it's not a joke. We're not trying to feel, poor when we want. No, we were poor. We probably still are. Not as, free from that as we wish. So I was in Tsakane, guys, Langerville, Mkhukhwini, before they built the RDP houses and all these things. I was there. And I went to KwaThema at Nkumbula Comprehensive School. That's where I did my high school, grade 10 till grade 12. Wasn't anywhere else where you would imagine I did. So again, parents, be realistic. If you cannot afford this private school thing, don't worry about it. Send the kid to the school that you can afford, okay? But push that little freak to study. Push that freak to understand what they're doing. Even if you're not educated, if you push them to do homework, you make sure they do responsible stuff at home. Because the other thing that parents miss, they think students need to be taught every time. I mean, I see this nonsense of teachers teaching kids from like 6 a.m. until 9, and then they start the normal school, and then they'll be at school up until say 4 or 5 p.m. Then they go and have, whatever, dinner or supper, whatever you call it. Then at 6 again in the evening, they have to be in class up until 9 p.m. I mean, come on, guys. What nonsense is that? There's no way kids are going to acquire the right skills and the right knowledge that way. It's just not possible. Remember, these are human beings. The brain needs a distraction at some point. Study when you feel you're not keeping anything you're doing. This already tells you your brain is saturated. Your attention has reached the roof at that point in time. So you need a distraction because the brain likes to see something new at some point. It doesn't like to see the same thing for the longest time possible. Yes, you can have a bit of endurance as you continue because also the brain adapts to what you subject it to regularly. So you can, of course, subject it to studying, but try to make sure that you balance your life out. And how do you balance this? At some point, do some sports, man. Play sports. Rather avoid TV because TV doesn't help as a distraction. In fact, it makes you lazy. It forces you to procrastinate. And at the end of the day, you become ineffective in your quest for good results. So TV is not a good idea. In fact, I hate that thing for school-going kids. A radio was important because it improves your imagination. When you hear people talk on radio, you just imagine the setup they are in. You imagine how they look. You even imagine their accolades in terms of education by just listening to their voices speak. Read books rather than to watch a movie live. Rather buy a book about a movie somewhere. I remember when I was doing grade 10, I went to Soweto at Dube, Lisedinyana Street, just next to, that guy who played Archie on Generations. I think it's 2 blocks away from my grandmother's house there in Dube, just near Dube station. So I would go there. When I went there for the first time, of course, when I was now older, because we used to visit there before I was a school kid. So when we went there, both I went there when I found that place, of course, because I was so used to working at home. So as I was cleaning there, they left me alone, so there was no one. So I just decided, okay, let me just clean, because what am I going to sit here and do? Watch TV? Nah, TV was boring. So I started cleaning, and then as I was cleaning, I came across a bunch of books in the shelves and stuff. So I remember I read a book written Kiss the Girls. It was about some doctor who was drugging girls and raping them and all that, and how this guy, Alex Cross, investigated him and found this guy, and how it was difficult to identify the men. Folks, you start to see the picture of what is going on. And I was so amazed to see a movie out of that book. In fact, the movie was so boring because it was not as detailed as the book that I read. So I was like, wow, can you imagine? The book is even more elaborate than a movie because, they cut out certain parts, and you start to realize that, okay, watching a movie after reading a book about that movie, it's actually not as entertaining as actually reading that book. So please, guys, read books so that your vocabulary grows. Also read. Try to read aloud and in the correct way. Stop this nonsense of these accents that you like. Just read normally, man. And get away from these crazy stereotypical accents. Of course, I'm not saying be coconuts, but come on, guys. Show some respect to the education you have acquired. There has to be something that says this person has gone through school. Man. Cannot pronounce words like someone who's just starting school, or who never went to school. There has to be a difference between the two. You see, guys, take highly your education. It is something really tremendous because it opens up a lot of opportunities that ordinary citizens would not get. Yes, it doesn't place you above them, because we need to remember we're human after all. Even with our education, we still need those who don't have it. So you cannot be too proud that you are educated and someone else is not. But there has to be a difference, though, between you and that person. Of course, in the advantage of the both of you. Because if you're educated, you need to bring an advantage for yourself alongside those in your circle or around you, so that they don't feel left behind. At the same time, they can appreciate that indeed you are a true leader in that regard, so that they can follow you in the right way, so that there's no discords, there's no problems, there's no infighting, but progress. Because that's the only way we can carve a path of success, guys, is that we become successful, but we shine that light of success also on those who could not, but who are right close by, or who are in our vicinities, so that we can have this mutual respect between the two. They can appreciate that you are higher, but you can also appreciate that they deserve to be lifted up high too, or that they can be brought along with. Okay. But in just ditch your sob stories, guys, that your parents don't have money. If you pass well, and this is up to you. Okay, there's books for free online. You don't need to buy textbooks that you cannot afford. You just have sites that have books that you can get for free, including your high school textbooks. There's lots of copies running around here in the country. So get those, And then, of course, there's old libraries in your schools where all the old textbooks that we used are. And trust me, those textbooks are still relevant because all the content in those textbooks is the one that you're doing right now. But I feel like the one that you're doing is watered down because it just gives you too much complexity with no meaning. As a result, you don't understand what you're doing, even though you can do it well. But you see, the old textbooks, they made sure you understood the concept so that the examination can be anything that you have never seen before. But we knew and we understood that with that knowledge, you would be able to navigate those questions. That's why there was a higher grade and standard grade, which was relevant in my opinion. Because not everybody can think in higher grade. But trust me, people who have excelled in standard grade, we know that at that time, if you get an A+ in standard grade, that was an equivalent of a B. Was it a B? A C, yeah. Standard grade, A+, were an equivalent of a C to a B in higher grade. So, I mean, we're not all thinking at the same level at the same time, but we are somewhat in the same level overall. Anyway, guys, Papa Yin, so teta kuze kubuyo yes, wapinda hamba, pinda buyi. I'm going to talk until Jesus goes and comes back and then goes again and maybe come back again too. So let's cut it here, guys. So you're going to find this in the description of this video, as well as the papers or the materials that I used for this lesson. Of course, Lesego said she wanted, or he wanted, a long video explaining these things. So I'm just trying to show you some things that you can just think of and use practically to survive your exams, of course, because remember, for you to progress, you still have to pass the exams. At least pass the exams then, right? And then if you don't understand, then you're creating yourself a steep hill because at university, you're going to keep failing. You're going to keep failing multiple times before you pass. So get into the habit of knowing things deeply, understanding things fully, and then applying your mind every chance you get, because that way you will not struggle so much at university. You will struggle. Everybody does. But the struggles are different in that the way we do things sometimes provides some advantages in certain areas. And of course, in certain areas, they become a disadvantage, in which case you also need to be flexible. You limit sometimes and you realize that your strong point is suddenly not a good match for a certain activity or a task. Then you limit on this and then you try to bring up the other side that you don't know. So that in life you end up balanced, you're not stereotyped. You are as dynamic as science itself. You are flexible. Anyway, folks, have a good one. Give a thumbs up. Watch these videos actively, not passively. You will see how far you're going to go. Otherwise, goodbye for now. Until next time.